Hello, everyone, and welcome to the online viewing session for February for the Kalamazoo Astronomical Society. I hope you all can hear me okay. Give me a thumbs up if you can hear me. Always got to do an audio check after what happened a couple of weeks ago. So it is great to have you all here. This is the absolute first time we have ever hit 100 on Zoom doing at least a meeting format. We had well more than that today for the webinar. Apologies for the slight late start. I am currently focusing the Takahashi. You always got to get the focus nice and sharp, so we give you good sharp images. And it's getting darker later and later now, and it is underway. But we are ready to go. So again, this is the online viewing session for February, the last of the season for the Kalamazoo Astronomical Society. And let's go ahead and just get right into it. So let me share my screen here, and you can see what I'm doing. So the Kalamazoo Astronomical Society remote telescope is located at a place called Arizona Sky Village. And specifically, it's located in this observatory called Pishi Observatory. So this is a 20 by 20 roll-off roof observatory. So as you can see, the roof rolls off to expose the telescope inside. So you can see the remote telescope peeking up there a little bit. And it's owned by KAS member Mike Patton. And going back to 2008, I believe, 2008, yeah. He came up to me at a general meeting and basically said, hey, Richard, I'm building this house and observatory at Arizona Sky Village. And I have room for 4 telescopes in the observatory. And if you guys give me technical guidance and advice, and once in a while, I'll give you a spot for a remote telescope in the observatory. And obviously, after a while, we said yes. And then we underwent a 7-year fundraising campaign, raised $122,000, 60% of which was by the membership. And we installed the main telescope at the end of 2015, early 2016, and then a kind of smaller secondary telescope that we'll start with back in March of 2017. And I think the scope, it's hard to say exactly when it became fully operational, but about a year and a half ago, it was basically operational enough to be used somewhat routinely. We're working out some technical glitches here and there, but it's been working fairly reliably now with just the occasional minor glitch that we can work around and no one really even notices. So Arizona Sky Village, it's located in southeast Arizona, very close to the New Mexico border. And, it's basically a dark sky community of amateur astronomers looking for very dark skies, which they have, of course, in abundance at that region. And it's near the very small town of Portal, which has about 100 people. And there's the Coronado National Forest nearby. And so, of course, national forest land cannot be developed. So Arizona Sky Village will stay dark for the foreseeable future. So it was a great site. And obviously the weather is much better than what we have here in Michigan, because right now it's probably 14 degrees out with very overcast skies and snow on the ground. So it is a great time to have an online viewing session. So this is an older view of Pishi Observatory, which, by the way, means Apache for Nighthawk. And now in the back here, there's a camera that looks like this. This is our S-Big All-Sky 340C color all-sky camera that shows you, the entire sky. So number one, we can check the weather, but we can also see what's going on above Arizona Sky Village. We can see, the currently visible stars and constellations and some other phenomena as well. So let me switch over to the web browser, to my web browser here. I just got to find it amongst the Zoom list here. And oh yay, look, so you can see the focus is done. That's good. But we want to go to this tab here. And so you should be able to see the all-sky camera. Somebody yell at me if you don't. So this is a live view, relatively live view of the all-sky camera. You can see it was taken at 7:02 local time. So it's about, this view is roughly about 5 minutes old. It'll refresh here because we take a new image every 4 minutes. And so the web page reloads every 4 minutes, but they're hardly ever synced together. It depends on when you actually log on to the website. And you can check out the all-sky camera whenever you want, day or night. So all you have to do is go to our website and click on the remote telescope menu. And way at the bottom there, you see our Pishi all-sky camera, and that takes you to this page right here. So we keep it running all day. So you can see the bright sun, hopefully blue skies during the day, and you can see all the wonderful stars at night. And you can see it's still not fully dark yet. So it's still getting dark, but obviously there's lots and lots of stars out now. And you see this shaft of light here that does kind of look like light pollution. But this shaft here is a zodiacal light, which is basically sunlight that reflects off dust in the plane of our solar system. And this dust can come from comets or micrometeorites striking asteroids. And it settles in the plane of the solar system and can reflect sunlight and create this sort of cone-shaped pillar of light. And if you can see the zodiacal light, that's a sign of very dark skies. I've never seen the zodiacal light from Michigan, but I'm sure it's visible from dark areas in the UP. And we see it routinely this time of year on the all-sky camera. Those of you that have been tuning into the online sessions for the past couple of months know the zodiacal light was over here, but now it's kind of shifted over here a little bit. And you can see over on the right here, that's the roof of Pishi, which is of course rolled off. And this little thing here is a bird perch to keep birds from pooping on our dome for the camera. And one of the neighbors has a red light there. You can see a little bit of light pollution there, but this is a 1 minute exposure, so it's a lot brighter than what it really is in the sky. So you can see some of the currently visible constellations over in the east, which is on the right, or I'm sorry, the west, which is on the right, is the Great Square of Pegasus. You can see the 4 stars that make up the Great Square. Of course, these 3 stars belong to Pegasus, while this one belongs to Andromeda. So most of the rest of Pegasus is lost in the glare of dusk there. So we are getting pretty far in the wintertime, but you can make out the, oh, there we go, I just reloaded. So you can make out the 2 arcs of stars that make up Andromeda. There's Alpheratz, which is the head of Andromeda, 3 more stars here, and 3 more on top that kind of run at a bit of a curve, and they intersect at Alpheratz there. And you can see a bit of a glow there. That's the Andromeda Galaxy, which we did look at back in, what was it, December, or no, November. No, December. Yeah, December. I don't know if we'll have a chance to look at it tonight if we have some extra time, but by the time we probably get to it, it'll be too low to image anyway. But of course, we have the winter sky over here. The fall sky is setting, the winter sky is rising. Most prominent is Orion the Hunter. You can see his 3 stars in a row, 2 above and 2 below. Of course, the 3 stars in a row are his belt, the 2 above are his shoulders, the 2 below are his legs. You can see the orange of Betelgeuse, a red supergiant that would extend beyond Jupiter if it were placed in our solar system. Over here, we have Bellatrix. This is Rigel, and Saiph, S-A-I-P-H. So if you drink some Betelgeuse, your belly will do some tricks, but if you take some Rigel, you'll be safe. That's how you remember that. And of course, the 3 stars in a row is Orion's famous belt. Hanging from his belt is his sword. Above his shoulders, obviously, is this little tiny head. You know, he's all brawn. He's not much in the way of brains. So he has a little tiny head. You can see his shield, and he's holding up this club right around there because he's being charged down by this V-shaped group of stars here called Taurus the Bull. The V-shaped cluster is the Hyades, But the bright star Aldebaran here, the eye of the bull, that is not part of the Hyades. It's actually closer to us, I think, than the Hyades. I could be wrong about that. And on the back of Taurus is the Pleiades, the famous seven sisters, which we have also looked at this season, but we'll definitely do it next season. And then up here is a house-shaped constellation called Auriga the Charioteer with the bright star Capella. Lots of good clusters in there. We did look at one last month. Over here, we have the twins, Castor and Pollux, in the constellation Gemini. It kind of looks like a rectangle, but you can make out kind of stick figures of people kind of here if you look hard enough. And down here, we have Procyon, which is one star of a two-star constellation. Procyon and Gomisa there that make up Canis Minor. And here we see Sirius, the brightest star in the night sky, which is the heart of Canis Major, the great dog. You can kind of see his triangular head here with a little stick body, kind of a stick front leg here, stick leg back there, and a kind of little tail going on. So, of course, Canis Major, Canis Minor are the hunting dogs of Orion. You can even see Lupus, the hare, below Orion there. He's stomping on it. But what else would you expect a hunter to do? So there's our current sky, and I'll try to come back to this from time to time. But if you watch this page on your own and happen to see a meteor, let us know. We can always hop back and check out a bright meteor or something. I have yet to see like a really, really good one on the all-sky camera. Oops. Okay, so as always, we're going to start with our Takahashi FSQ 106 EDX3 telescope. This is the 4-inch refractor that rides piggyback on top of our main telescope. Some people wonder why we just don't use the big telescope, but as you'll see, the Takahashi telescope can do some pretty amazing things. It costs more than many big telescopes from me, like a 10-inch Meade Schmidt Cassegrain. So it's a very, very high-end refractor with incredibly sharp optics. And you can check out the specifications here. Again, it's basically a wide field 4-inch refractor. If you do go to our website and go to the remote telescope section, there is a page called Instrumentation where you can learn more about all the various cameras and instruments that we have for that comprise the remote telescope. The camera is an SBIG STX 16803 CCD camera. I know CMOS cameras are starting to take over, like what you have in your DSLR camera or your smartphone, but this is still a very, very high-end camera. Maybe not by resolution standards today, but for astronomical purposes, it's very high resolution. So this is a full frame CCD camera with a nearly 37 millimeter square chip. So that's pretty good size compared to most cameras, even still today. And yeah, it's only about 17 megapixels, but for astronomy, it's perfectly fine. Resolution doesn't make a whole lot of difference for things we see in the sky because of the Earth's atmosphere. And it is a monochrome camera, so all the images that you're going to see tonight will be grayscale. We won't have any color images because to do color images, you have to take it through red, green, and blue filters. And for a session like this, we simply don't have the time to take the images, let alone to process them. But we do use a monochrome camera like this for fine, high-resolution astrophotography. And our very first target tonight will be Orion's sword. Last month, we looked at the Orion Nebula up close with the 20-inch, but this month, I always like to take a look at it with the Takahashi as well. So let me tell you a little bit about Orion's sword here, but while I do that, let me hop back to the browser, and I should probably get the exposure started. So here we go. Let's just see what I'm doing here. Of course, I can never get to the tab because the Zoom stuff gets in the way. So this program here is called ACP, or the Astronomers Control Panel. This is specifically the ACP web interface. So if you are a Kalamazoo Astronomical Society member that does live in the Southwest Michigan region, You can sign up to use the telescope and take your own images. And you don't need any special equipment or software. You just need a web browser with high-speed internet access, or reasonably high speed. And you can just control the telescope through this web browser. That's all you need. So I already got it keyed up and ready to go. I'm just going to hit that just to be safe. And I think we'll just start off with a 2-minute exposure through a clear luminance filter. So I'm going to hit that, and it'll begin to slew to the target. And look for a guide star, although we really don't need it for a short exposure like that with the Takahashi. And it'll start taking pictures. Okay, so still quite amazingly, the Orion Nebula was not known to pre-telescopic observers, which is just amazing because you can see it as a glow in the sword of Orion. And it was first discovered by the French astronomer Nicolas Claude Fabry de Pishi on November 26, 1610. And the first published observation of the Orion Nebula was by the Swiss Jesuit astronomer and mathematician Johann Baptiste Cdk in 1619, and he compared it to a bright comet discovered in 1618, the year before. So the first published sketch was made by the famous Dutch astronomer Christiaan Huygens in 1659, and none other than Charles Messier observed it himself on March 4th, 1769. It was already fairly widely known, but he added it to his famous catalog of objects that might look like comets but aren't comets, and turns out to be some of the best objects in the sky. And the first ever instance of astrophotography of the Orion Nebula, or of any nebula, goes to the American doctor, amateur astronomer, and astrophotography pioneer Henry Draper. He used an 11-inch refractor to make a 51-minute exposure of the nebula September 30th, 1880. And I think I've seen that image before. I should probably look for it and include it in here sometime. But what we're going to do here in about 2 minutes will exceed what Henry Draper did with a 51-minute exposure easily. So everyone, I think, knows where the Orion Nebula is, and Orion's sword. It's, of course, in the constellation Orion, and hanging from his belt in the sword here. And so here's the view. The previous view was with Starry Night. This is with Sky and Telescope's Pocket Sky Atlas that I scanned on my scanner. And if you're looking for a nice Sky Atlas, I highly recommend Sky and Telescope's Pocket Sky Atlas. And so last month, again, we just kind of zoomed in this region, but the Takahashi can encompass the entire area of Orion's sword there. And we can zoom in for a closer peek. So we'll be able to see M42, which is what we usually think of as the Orion Nebula, but M43 is also part of the Orion Nebula. And then we'll be able to see some nebulosity up here that we'll look at closer with the 20-inch later. There's an open cluster above that called NGC 1981, and some nebulosity below that we'll all be able to see in the view of the Takahashi. So let's hop back to the web browser, see how we're doing. I've heard some beeping going on in my head here that I'm not sure you can hear. And you can see ACP, the Astronomers Control Panel, has already automatically acquired a guide star and has begun its 2-minute image. So we don't have too long to wait, but let me go ahead and stop sharing the screen here and just again say hi to everyone. So if you if anyone has like a quick question, we might be able to answer a question or two, or if anyone just wants to say hi, you can unmute yourself and just say hi.
Hello.
Hello.
This is really a lot of fun. Thank you.
You're very welcome. It's great to have you all here tonight.
This is Rick from Grand Rapids. Appreciate this.
You're very welcome. I'm glad you could make it.
I'm from Philadelphia, Pennsylvania, and I'm delighted to be able to look at Arizona.
At least the overhead part.
Yes, indeed.
Of course, if you see if you look around for the people that are logged on, you can see a guy named Mike Patton. So he's actually in the observatory right now in the warm room, or sometimes a cooling room, but right now it's a warm room, I would imagine.
Hi, Mike.
I'll try to check the questions in the chat when I get time. Normally with the online viewing session, we like to have a little interaction as opposed to the lecture that we did earlier. And I do want to say hi to those watching on YouTube. We got 42 watching on YouTube that got locked out of the Zoom meeting. I thought about switching to the webinar, but you know, it's just no fun to talk to the computer and not see anybody or interact with anybody.
Hi, Richard. It's Martha Testa from Brockton, Massachusetts. I love it. I'm in Massachusetts, you're in Michigan, and the telescope's in Arizona. I think that's so cool.
It is. It's very cool.
Rich,
All right,
this is another
I'm in
Rich from Sun City,
freezing
Arizona, with the following question. In about 10 minutes, the Space Lab was going to go over us. Not tonight, but is that something you'd catch with your, you'd be able to catch somehow, or?
I've never looked for the space station on the all-sky camera, but it should have no problem picking it up. It's just that we do a 1-minute image every 4 minutes, so we won't get very much of it if we do.
Right. Thank you.
All right, let's see how we're doing. Let me switch back to the not the PowerPoint. That's the wrong screen. Looks like we are done. So got to make sure I got so many windows open. I got to figure out which one to go to here. I think that one will work. Okay, so looks like the exposure is complete, and I see a image. So let's click on that and check it out.
Oh, cool.
Wow.
Wow.
Fantastic.
See, that's why I like to do the Zoom meeting, so I can hear people
Wow.
go ooh and ah.
Incredible.
That's so cool.
It's amazing. Even in black and white, it's amazing.
Very cool.
So let me tell you a little bit about what you're seeing. Obviously, the Orion Nebula is so famous because it's not the closest region of star formation, but it's the closest region of massive star formation to Earth. M42 is 24 light years across and has an estimated mass of approximately 2,000 times that of the Sun. Inside the Orion Nebula is an extremely young open cluster, only about 300,000 to 1 million years old. And yes, that is young for a cluster of stars. And it contains about 300 members that's just now slowly emerging from the Orion Nebula. And again, this part here is M43, which is part of the Orion Nebula and surrounds what's known as Bond's star. You can just barely see it in this image here. And then we have NGC 1980, is known as the Lost Jewel of Orion, and was discovered by William Herschel on January 31st, 1786. And this, I think this is, I forget where 1980 is. I gotta go back and look at the chart. But up here we have 1981. North is at the bottom in this view, and this is the northernmost part of Orion's sword. There is it's a loose gathering of 20 or so stars spread across an area about the sky of the full moon. And then there's 1981, which measures 11 light years. I should have had a star chart handy, star atlas handy, so I could remember which part is which there. And of course, you can see the Orion Nebula up here. This is called the Running Man Nebula. We're going to look at that up close later with the 20-inch again. And you can just see hints of dust all around. And if I did a much deeper exposure, it would just reveal more and more dust. And if you do look carefully, you can see a satellite, because there's like one here, one here. Every time we do an image of the Orion Nebula, at least from Arizona, we get a satellite or more going through. They're always there. We have these like constant satellites fly by. I think many of them are geostationary. So there is the Orion Nebula for your viewing pleasure.
That's
Remember,
amazing.
At the end of the session, I will give you a link where you can download the full resolution JPEG version of these later so you can zoom in. So you'll be able to see this in a lot more detail. Probably sometime tomorrow, I'll get these processed and uploaded to the website. We might peek at that again later.
Somebody asked, Richard, someone asked in
Yeah.
the chat, what is the field diameter of that image?
Oh, that's a good question. The Takahashi has a field of view of about 4 inches, about 4 degrees square. The 20-inch has a field of view of about 36 arc minutes square, a little more than half a degree. So this is 4 degrees, while the main scope, the 20-inch, has a field of view of only half a degree. So you can see why we have the Takahashi, to take in wide field scenes like this. All right. So our next target is going to be NGC 869 and NGC 884. Let me bring up the slide there. So, but I got to get the image started. So let me hop back here real quick. And I was going to try something a little different. Instead of centering the clusters themselves, I wanted to input some special coordinates. But I'm going to type in. You got to type in something here, because I wanted to frame this maybe a bit differently. And we should have some time here, because most of the images we'll do tonight won't be horribly long in terms of exposure. So I thought I would frame it just a little bit differently. Just a second. Let me type in the right ascension and the declination. So it's positive this time.
Oh, cool.
All right. I think we'll do, let's try 3 minutes. I think that'll be pretty good. And off we go. All right.
This is very cool. Thank you very much.
You're very welcome. So the double cluster, NGC 869 and 884, is also known as the H and Chi Persei cluster, or they're known as H and Chi Persei. It's also Caldwell 14 in the Sir Patrick Caldwell Moore catalog, but he named it the Caldwell catalog because he can't use M as in Moore, because that would confuse it with the Messier catalog. And the double cluster is basically a 4th magnitude knot that stretches about 2 moons in diameter. And the double cluster represents the jeweled handle of Perseus's sword. The Greek astronomer Hipparchus cataloged this object as a cloudy spot near Perseus as early as 130 BCE. And William Herschel was the first to recognize this object as 2 clusters. So here we can find the open cluster, technically in the constellation Perseus, but it's between Perseus and Cassiopeia here. And we can zoom in for a closer look here. It's located about halfway between Delta Cassiopeiae, right there, and Gamma Persei. It's about 25 arc minutes, and the two are separated by about 55 light years or so. But they are a true double cluster. They are relatively near each other in the sky, but they're both about 55 light years, I think, across, not apart. So the way I'm framing this tonight is I framed it so we have the double cluster toward the bottom of the image, and we'll get a little bit of stock too. It's a fairly sparse cluster, but I thought it might be a little fun to frame it a bit differently and get a little more action in there. And if we're sharp, maybe we can, if I have it framed just right, we might get NGC 957 there. So we'll hop back to the browser real quick. I can hear the computer working. Again, I always lose the browser. I know I had trouble with the guide star last night, and it's having trouble with the guide star over there again. I'm not quite sure what the problem is, but we really don't need the guide star for the Takahashi. So if it doesn't find one, I'm not going to lose any sleep over it. I can give you a behind the scenes view. So of course, this is the web interface, but let me actually show you the computer, what the computer screen looks like at the observatory. So here we go, and you can see over on the right here, this is actually ACP itself. So ACP is kind of the Swiss Army program. It's basically a program that controls programs. So ACP controls the program here in the center called Maxim, which controls the camera and the auto guider. And then we have a program here called Focus Max, if I can get it to pop up. It's being temperamental. Well, Focus Max is behind there. There it is. So this is Focus Max. Whoop, there it goes, which does the focusing for us. And there's also the Sky X. I don't know if I can pop that up for a second. The Sky X is basically your garden variety desktop planetarium program. And that's what controls the mount. There it goes, which controls the telescope. So ACP works with the Sky, Maxim, and Focus Max to bring the remote telescope to life. And you can see we have acquired a guide star. Just took a little longer than usual to lock it down. And now it's doing its 3-minute exposure here. So we're a little ways into our 3-minute exposure. We can, whoop, wrong one. Just real quick here, we'll hop back to the web browser. See how we're doing there? You can see it's gotten a bit darker. Someone has their nasty light on somewhere else in Arizona Sky Village. Mike, sick 'em. Tell them to go turn that light off. We can still see the zodiacal light, and it's getting very, very dark. And I think our all sky camera has lost a bit of its focus. Things do look a little fuzzier than they have before. So we might have to periodically tune the focus. You know, there's temperature changes and stuff like that. So little tweak of the focus might be good. All right, let's see. I can try to hop through the chat real quick.
I have a question for you, Richard.
Oh, sure, go ahead.
Just curious, what gives you, or what do you use as a determination to whether or not it's going to be a 2-minute exposure or 3-minute exposure when you do take the photos?
Again, just practice and just a little bit of basic knowledge. You know, you get an idea of the sensitivity of the camera when you first start to use it. Sometimes you can overexpose stuff, but I try to keep the exposures down for us. But usually for the Orion Nebula, if you want to at least get the center of the nebula, the trapezium region, you want to do relatively short exposures. But the great thing about today's photography is you can do a series of images, you know, from 30 seconds to as much as maybe 10 minutes of the Orion Nebula to capture like a high dynamic range of the entire region to pick up not just the trapezium, but the extended dust cloud and so on. Of course, Lloyd at first thought the dust cloud was basically funky noise with the image, as I recall him saying during Astrophoto Night one time. I see him shaking his head there.
A question about your sky camera shot there. What projects on my screen, there's a little bit of a light band going from the lower left to the upper right. Is that something in your system? Or is that sky? Is that...
I'll have to go back and look at it. Off the top of my head, I'm not sure.
Guy says the Milky Way, and I had that thought too, but I don't know.
Oh, okay, is it in the image? Okay, so it's probably the Milky Way. Okay, we'll go back and take a look at that. But I think I heard our image complete there. So let's hop back to the browser. Of course, we have to go back. So yes, this is the Milky Way. And I can't get to the thing again because the Zoom stuff gets in the way. So okay, we're all set there. Let's click on it and see what we got. Obviously, it looks like we got a bunch of stars. And at the bottom there, you can see the open cluster, open clusters. I always forget which is which. So obviously one of these is NGC 869, the other is NGC 884, the famous double cluster. And it's hard to pick it out amongst the stars of the Milky Way, but up here is stock 2. But what we have here, all this other stuff, that is basically stars within the plane of our galaxy. So both these clusters are about 12.8 million years old. If you want to ask me how we know that later, you can do that. It's more than 300 blue-white supergiant stars in each cluster, or there are more than 300 blue-white supergiant stars in each cluster. The double cluster resides in the Perseus arm of the Milky Way galaxy, more distant from the galactic center than the Orion arm. It would appear about 4.4 times brighter, if not for thick clouds of interstellar dust between us and the nebula here, or the cluster here. If we could place this at the distance of the Pleiades, about 400 light years, it would span 5 moon diameters and shine 300 times brighter than they actually do now. And 1/4 of the sky would be filled with the concentrated splendor of 600 stars. So darn it, how come the double cluster can't be at the distance of the Pleiades? And I don't know much about stock 2. For the most part, the stock clusters are fairly sparse, but it is hard to pick it out amongst the many, many stars of the Milky Way. Any questions about the image while we have it up?
What is that streak of like stars coming right up toward the middle of the image from the
Here?
Right here now says
Yep.
that one.
That's basically a chain of stars. I don't know if they're related to the cluster. It would seem like they are, but gradually open clusters do erode over time. They encounter, alien stars outside the cluster. These could be stars that have been gradually stripped away from the clusters proper here. But a cool thing with binoculars is when you do look at this region with binoculars, the double cluster looks like the slash in a Q. There's like a big arc of stars all around that make like a giant letter Q in the sky. So that's a thing to check out with binoculars. And we'll go ahead and take some time so you can count the stars too. Like jelly beans in a jar. Maybe we'll give a prize away if anyone gets the right answer. Of course, someone would have to know the right answer, which isn't me. Anybody else have any questions on the double cluster? All right, we'll go ahead and close that. But remember, you can download the big one later. Now, before I hop off, let me remember to put in our next target. So it is also an NGC object, but it's 2244. This time we're going to get a little crazy. I'm going to bump it up to 10 minutes. And we're going to switch from the luminance filter, which is a clear filter, to the hydrogen alpha filter. We'll explain that later.
Hey, I have a question regarding doing star trail photography, especially with DSLRs. Do you have any tips or any resources where we can go to that's not on, Wackadoo or somebody's, particular project that, would be good for use of time and practice?
Off the top of my head, not a particular website. I know some other members here do astrophotography. So if anyone knows a good website and how to do star trails, it's not really that difficult to do. You just need a DSLR camera. I think even smartphones could probably do it now too, as some of us were discussing today. But you want to get yourself kind of a wide angle lens, depending on the size of your chip. If you have the standard APS size chip in your DSLR, I think like a 18 millimeter lens will do, a wide field. And just set it to do a series of maybe 30-second to 1-minute exposures on a stationary tripod, making sure to point the camera toward Polaris. And just take, as many exposures as you can over maybe a 1 hour period or more. And there is a program to create the star trails that's called, are you ready? Star Trails. So I haven't downloaded it in a while because I don't get to dark skies to do star trails very often. But you can go just do a Google search for Star Trail software, and it's basically a program that loads the images in for you and stacks them and creates a star trail for you.
Okay, well, that's perfect help because I ended up actually overexposing my DSLR a couple times. I tried it. I definitely could see my tree get really, really light, as if it wasn't dark. So tremendous help. Thank you.
Yep. Okay, so our next target is NGC 2244, the Rosette Nebula. So we're going to do another nebula. So as you can see, this nebula is 4.8 magnitude, but it is nearly 24 arc minutes across, which is almost the size of the full moon. I think I noticed somebody in the chat earlier asked what an arc minute was. So an arc minute is like 1/60th of a degree, because 1 degree is equal to 60 arc minutes. And if you hold out your pinky at arm's length, that takes up about a degree of the sky. So one pinky length at arm's length is about 60 arc minutes. So this is less than half that, but it's fairly comparable to the size of the moon. But because of its size, it is kind of hard to see, because with these dust and gas clouds, as they do get larger in our sky, they actually tend to get fainter. So of Monoceros's 60 stars, you can see Monoceros here, the unicorn, none shine brighter than magnitude 3.9. So amongst all the flashy stars of the winter hexagon here, Monoceros tends to get lost because it is a difficult constellation to see. So the Rosette Nebula is located about halfway, at roughly the halfway point between Procyon here and Betelgeuse, as you can see, maybe a little closer to Betelgeuse. And the nebula has several NGC designations, or New General Catalog designations. There's NGC 2237, which is a cluster, NGC 2238, another cluster, NGC 2246, and they're all parts of this nebulous region, while NGC 2244 is actually the bright cluster in the nebula's center. So it is broken up into several parts, as you can see from the sky atlas here. And at its largest extent, though, it can cover 4 times as much sky as the moon, but it's about 3 times as far and 3 times the size of the Orion Nebula. So if it were the distance of the Orion Nebula, it would be 3 times larger. So it would look, it would fill up a good chunk of the bottom of Orion. It would make it look like Orion had like a big puffball on its belt or something.
Was this 1 degree west or away from Canis Major or Minor, excuse me?
Yeah.
Okay, that's what I thought I heard. Thank you.
And so here's a close-up view again of the Rosette Nebula with all these various NGC objects. The Takahashi will encompass a great deal of the field of view here, so we'll be able to see many of these sparse clusters as well, but the nebula will really draw your attention, as we'll find out there. And this is a 10-minute exposure to really bring out the nebulosity. You should really enjoy this one. So we'll just stop sharing the screen there. And again, if we have any more questions or any more comments, feel free to ask. We have some time this time.
You had mentioned that, well, somewhere along the line, somebody mentioned an astronomer's notebook and how you record what you see. Is there does everybody just create their own system, or are there things that you can actually purchase to use for record keeping, or start with that?
There are programs where you can enter in your observations. I can't name one off the top of my head, so if anyone else knows, you can chime in. I think there's one called, one comes to mind called Deep Sky Planner, where you can plan your observing, but you can also enter in your observations. But you know, if you're old school, you can also enter them into a notebook. I tried in the very early days of computers when I had a Macintosh and this old program called ClarisWorks. I tried to enter in all my observations in the data bank, and of course that's a long obsolete program, so all those logs are lost. So frankly, I would just settle with a good old-fashioned sheet of paper, or like a scientific notebook, and create your observational log that way. You can print out star charts, or put your sketches in there, and I think that'd be a lot better. You know, sometimes the old school ways are better than the new school ways, because new school tends to get outdated and then you can't access it anymore, like my old observations I entered into that database in ClarisWorks, which is long obsolete. I saw somebody ask,
Also,
what type of nebula is the Rosette Nebula? Just real quick here, Kevin. The Rosette Nebula is an emission nebula. Go ahead, Kevin.
just as a quick follow-up for the observing notebook. I would suggest, if you're just starting out, to use like just a notebook that you would take notes in for college or something. And the nice thing about that is you can have it when you're out observing and take notes as you're actually looking at things, instead of having to wait to go home to put it on your computer or your iPad or something. And you can also sketch what you see.
Yeah. And another great thing is today they have those digital recorders. Of course, I think you can do it in your phones as well. If you don't like to try to take notes at night, you can dictate all your observations into the recorder, and you could write them down later. Especially in the winter when you got gloves on, you don't want to take them off to be able to write. So it's probably just better to talk into a recorder, unless your recorder freezes and then you can't use it. But you know, what are you going to do?
Richard?
Yeah.
Roy in Ohio, I have a question about the roof. Does it open automatically at dusk? Do you have to open it?
No, it opens along with the program. So there's a routine in the startup script that opens the roof.
And,
quite often.
And does that coordinate with anyone else who's using any of the 3 other scopes?
No, not yet. I haven't. I forgot to do this. Let me let me go to the browser there. So there's the actual telescope right now. I'm glad you brought that up. So Mike Patton has this little quail here. You see the little quail?
Mm-hmm.
That's his little new system to tell us that he's using the observatory. So if we see the quail there, we're not supposed to close the roof because one of his telescopes won't have any issues, but his refractor will, because that could get hit by the roof. But there's other ways we can check his progress. But currently, we've talked about that. We're going to maybe put limit switches or sensors on his refractor so the roof knows it can't close when the refractor's out of position. But you can see this reflector here. When the scope slews back to the park position, the system will detect that and it'll say the roof is safe to be closed. So this is the telescope live right now. You can see the flip flap here of the Takahashi is open. So if you ever see the flip flap open, you can tell that we're using the Takahashi. And again, you can go to the remote telescope menu and select the Pishi Observatory webcam to view this page. It does not run very well on Firefox. It plays for maybe a few seconds and then pauses. So it runs best in Google Chrome, or as I'm using here, Microsoft's Edge browser. It's a unsecured video. So to get it to run in your browser, we have instructions down here for how to give your browser permission to view the camera. So if it is a clear night in Arizona, you can check out if the telescope is in use. So I always forget to go view the telescope in real time. If I remember, I'll switch over when it's slewing to a target, but right now it's still doing its exposure of the Rosette Nebula. We should probably check in to see how we're doing. Oh, we're doing good there. We're only got less than 100 seconds left. We found that guide star. We're guiding away. The guiding looks pretty good. And we're almost done there. Any other quick questions while we're waiting? Anybody else want to share where they're viewing from that hasn't shared already?
Boulder, Colorado, and thank you.
Oh, fantastic.
Hi, this is Chris from New York City.
Whoa, New York City.
Hi, this is
I've
Dwayne
been
from
taking
Montana.
your course, the lectures.
Oh, great.
This is Sue from Groton, Massachusetts.
Oh, another person from Massachusetts. And did I hear somebody's from Montana?
Yes, Dwayne. from
Oh,
Montana.
big sky country.
Yes.
Fantastic. I was almost there, but I was only in Saskatchewan.
Oh.
I didn't quite make it across the border. I tried going to the Saskatchewan Star Party one year, but the weather was about as worst as I think they ever had. So
right.
They can thank a Michigander for bringing the bad weather to them.
Yes.
It never fails.
Well, I can tell
Hey,
you.
we were close to Montana for the eclipse.
-13. It's a lovely brisk -13 in Wisconsin right now.
Wow, you got it worse than we do.
Yeah, the wind is whipping.
Yeah, the lake tends to warm things up for us a little bit, so we don't quite get as bad as you guys do on the other side. You give us the lake effect snow though, so thanks a lot for that.
This is Rick and Joy from Eureka, California.
All right.
Oh. This is Alan from Bangor, Maine.
Oh, wow.
Very cool.
I viewed the 2004 Transit of Venus from Maine.
Really?
Yep.
Where'd you go?
Yeah.
It's complete.
It's been so long, I forgot. Yeah, I see that. You have to wait for it to load. All right, our image is done. So let me click on it.
Ooh.
Wow.
It is.
Oh my gosh.
That's the real Rosette.
Very nice.
That's incredible.
Awesome.
Yeah, it's beautiful.
So you can see why they call it the Rosette Nebula. So the nebula surrounds the cluster NGC2244, as I mentioned. So you can see NGC2244 right there, which contains about 100 members and formed within the past 5 million years. The cluster itself is 43 light years in diameter, while the nebula can be as much as 130 light years across. The nebula has an estimated mass of about 10,000 times that of the sun, making it one of the most massive emission nebulae known. And I saw that Craig in Oklahoma already mentioned this in the chat, but on April 16th, 2019, the Oklahoma legislature passed HB 1292, making the Rosette Nebula the official state astronomical object. And Oklahoma Governor Kevin Stitt signed it into law on April 22nd, 2019. So there you go, Craig. This nebula is for you.
Yay.
The clarity is amazing.
It is. That's the great thing about having a thermal electrically cooled camera. The camera is cooled to -20 degrees Celsius. So it gives very noise-free, sharp images. Makes it very sensitive too.
So if you were to transfer this to color, this is going to be a much sharper image to work with.
Yes. Yep, because monochrome cameras are inherently sharper than straight to color cameras. So that's why we take images through, say, hydrogen alpha to bring out the nebulosity, and then use red, green, blue to bring out the color. And also hydrogen alpha dims down the stars a little bit, because if we did an image with the luminance filter, the stars would kind of overwhelm the image a bit. So H alpha really brings out the nebulosity and kind of tones down those stars. And just wait until you get the full resolution image and you can zoom into it. That'll be really, really cool. All right. Any more questions or comments on the Rosette Nebula? I don't want to get rid of it too soon because we waited so long to get it.
Richard, below the central area, you've got like an upside down Y, like a line that comes down and then splits.
Like here?
Up higher in the actual rosette itself.
Oh,
Yeah, right
like
there.
this dark nebulosity? Yeah.
Is that what it is? Is it a
Yes.
dark nebula?
Yes.
Perfect. Thank you.
Yep. So you can see the Emission Nebulae. It's filled with patches of dark nebulae that aren't being illuminated by this star cluster here.
Hi, this is Charles, and I have a question. And I would like to know, can we use DSLR to take this picture?
Yes, you can. Of course, the DSLR won't be as sensitive because they can't be cooled, although there are versions that you can buy cooled. But those are kind of starting to go away now because there are electrically cooled CMOS cameras that use the same chip as your DSLR, but become much more sensitive when you cool them. There's many companies that make these, like ZWO. Those are Chinese imports, but they're actually very good cameras. There's QHY that make very good cameras. Even SBIG is beginning to segue from CCD cameras to CMOS cameras. So in some ways, our CCD is becoming a little outdated, but it's still pretty sharp. I would not trade it for the world.
Great, thank you.
Yeah, you're very welcome. But yeah, you can take an image like this with a standard DSLR camera. It just takes practice. Okay, so as we'll see here, we're going to switch telescopes now. So I'm going to hit this button here, but somebody has to remind me to make sure I change the aperture and focal length and ACP before we start imaging again, because I always forget to do that. I'm very bad about that. Sometimes I put notes right in front of me, but I don't pay any attention to them. I'm very, very bad. Oop. Okay, so we should be back on the PowerPoint slide there, and we are going to now switch to our main telescope for our main event of the evening. It's always our main event. So, of course, here we see the Takahashi. But below the Takahashi, which we just got done using, you can see our plane wave Cdk20 telescope. The Cdk means it's a corrected dull Kirkham, which basically means it has an ellipsoidal primary mirror and a spherical secondary mirror with a lens group in the back to help give nice, sharp images across our field of view. Oop, how did I do that? And as the 20 suggests, it is 20 inches in aperture, which means it has a primary mirror 20 inches across. So we're going from a 4-inch to a 20-inch, but the sacrifice is we get more light gathering power, but we sacrifice the field of view. So again, the field of view of the plane wave is a little over half a degree. And yeah, it does weigh 40 pounds. And we can zoom into the back here and we can see the imaging train of the Cdk20. We use the same exact CCD camera that we have on the Takahashi. That did cause some problems early on, but we have that all sorted out now. And both cameras have a SBIG filter wheel that contains 7 filters in all. There's LRGB, luminance, red, green, blue filters, and narrowband filters like hydrogen alpha, which lets through specifically red light. And then there's also oxygen 3 and sulfur 2 filters. This little box on the back is the focuser. We have what's called an on-axis guider. That would take too long to explain. And this is the actual auto guider that guides on a star to keep the images nice and sharp. Again, we don't really super need it for the Takahashi, at least for short images, but we need it a little more for the plane wave, since it is a pretty big telescope. And what points the plane wave and Takahashi around the sky is our mount. This is a software BISC Paramount ME2, their beefiest equatorial mount. It does have a 240-pound capacity, and we're probably using about roughly not quite 200 pounds of that, somewhere around there. So we're not quite anywhere near tapping the capability of our Paramount, which is probably good. You don't want to push it too hard. And I think I did hear a little ding ding that says we are done. So let me, we have switched telescopes. and we're nearly cooled down to the minus 20 degrees C. But before I switch back, let me enter in our first target for the telescope here.
And don't forget your settings.
Yes, I got to remember to, oh, that's right. So let me do that right now. I'm not going to bother switching screens here because I will forget. I can't walk and chew gum at the same time. Because the one bad thing about ACP is it can only work with one telescope at a time.
Are we going to look at the same cluster in order to compare the two telescopes, or?
No, not really. We are going to look at the Running Man Nebula, which is above the Orion Nebula that we did see before. So you'll definitely get a comparison between the two then.
Hear you.
But boy, does it look different when you see it up close. Okay, I think I'm good to go there. And oh, where was I? I lost track of where I was. I told you I can't walk and chew gum at the same time. Oh. Okay, so I got NGC 2261. Make sure I hit get coordinates in case I forget. We'll keep this one fairly short because it's pretty small, pretty bright. And we're going to stick with the luminance filter on this one. And away we go. All right, so we're doing good there. We're often using the scope. And so here we go. Our first target with the 20-inch is NGC 2261, Hubble's Variable Nebula. This is something I've been wanting to do for a while. It's kind of one of my little favorite off-the-kilter deep sky objects. This is also known as Caldwell 46 in the Sir Patrick Caldwell Moore catalog. And as you can see, it is roughly 9th magnitude, but it does vary in brightness, hence the name Hubble's Variable Nebula. And it's not one of our bigger objects that we'll look at. So it will look a little tiny in the image, but you know, again, you will be able to zoom into it later. And of course, part of the reason why it is tiny is that it is 2,500 light years away. So like the Rosette Nebula, the Hubble's Variable Nebula is actually located very nearby in the constellation Monticello, so the telescope will not have to go very far at all. So that gives you a rough idea where it is, but it is located about 4.5 degrees southwest of Xi Geminorum, which is called Alzir. So 4.5 degrees southwest of this star right there. You can find NGC 2261. And you can see the Rosette Nebula here. So if you do see the Rosette Nebula in binoculars, it's not too hard to track down Hubble's Variable Nebula, but it is a lot smaller than the Rosette Nebula. This was discovered, like many objects we look at tonight, by William Herschel on December 26, 1783. And this was actually photographed as the 200-inch Hale telescope at Palomar Observatory's first light by none other than Edwin Hubble himself on January 26, 1949. But that's not specifically why we call it Hubble's Variable Nebula. He studied it years earlier. And Hubble's Variable Nebula is thought to be about 1 light year across. But again, the first object, the famous 200-inch Hale telescope ever looked at was this object that we're going to check out now. And this was the world's largest telescope from roughly 1948 to, I say, 1993. Some sources say 1976, but that includes a Russian telescope that was larger but never worked very well. So I don't count that one because it never really worked. All right, so let's switch back to the browser again. And we are already guiding. We are already a minute plus into our exposure. So do I hear a question?
This is Chris. I have a question. So you're a Michigan Astronomers Club, but your telescope is in Arizona. I can only assume because the skies are awesome in Arizona?
That's part of the reason that the skies are awesome in Arizona. Michigan's very cloudy. We have a lot of light pollution here, so this is kind of the wave of the future. Many high-end astrophotographers have already done this. They've moved their telescopes to remote sites because, of course, we all have to suffer from light pollution. So I think more and more clubs that get the means are going to do this. They're going to basically move their telescopes to darker skies to do at least imaging.
Wow, that's pretty cool. I said I'm in New York City, and I'm in 2 different clubs, but they don't have. I'm supposed to go Monday, but we're gonna get snow, so they have like the field trips, and I bring my telescope, but there's no one that they have this, like, the remote telescope. That's like pretty awesome.
Yeah, there aren't too many clubs that have a setup quite like this yet, at least a one as remote as ours. I know there's a club in Ontario, the North York. They have a remote telescope, but it's basically in their area. So there aren't, you'd be hard pressed to find a club that has a remote scope like ours so far away. For us from Kalamazoo, it's a 28-hour drive just to get there to service the telescope when we need to. But fortunately, we do have one member often on site, Mike Patton, but he'll be leaving in either March or April. So we'll be kind of on our own from there. But there are some year-round residents at Arizona Sky Village that do help us out from time to time. We do shut down the telescope during the monsoon season from July through September, but quite often we're usually out under the real thing because that's when we have clear skies around here in Michigan.
Oh, very interesting.
Telescopes are at the Sky Village.
Mike could probably answer that. There are quite a few observatories now, probably more than I knew of when I last visited in 2017.
What was the question again?
She asked how many telescopes are at Arizona Sky Village.
I'd have to spend some time counting. I'd say 25 to 30. Some of them are bigger than this. Some of them are remote.
Yeah.
But most people are in the village, are retired, and they're here with their equipment when it's operating.
All right, so we are done. So as you can see, it's right in the center there. So let me click on that. And there we go. So I just love this object. Even probably 3 minutes was a little bit on the long side because I did overexpose it a bit. But I just had this fond memory of back in 1995, not long after Comet Hale-Bopp was discovered. We looked at Hale-Bopp one night, then like a month or two later, when we get into wintertime, I looked at Hubble's Variable Nebula and I'm like, man, it looked just like Hale-Bopp, because there was a point when they were like the spitting image of one another. So let's tell you a little bit about this object. The nebula is illuminated by the variable star R Monocerotis, which is a T Tauri type variable star, which itself is not directly visible. R Mon, as we'll call it for short, has a smaller dim companion. The bigger star has about 10 solar masses and is about 43,000 times the luminosity of the sun. Edwin Hubble was the first to realize in 1916, while working at Yerkes Observatory, that the nebula also changes in brightness. So that's why we call it Hubble's Variable Nebula. So it changes shape over a period of just days and can vary up by 2 magnitudes in brightness. If you do a Google search for NGC 2261 animation, you can find animations of it varying in shape and brightness over time, but it only appears to change in shape because of basically shadows being cast. So that's one explanation for the variability, is that dense clouds of dust near R Mon periodically block illumination from the star, and this casts temporary shadows on the nearby clouds. So the variability of R Mon is between 9.5 and 13th magnitude, and it was actually discovered to vary by someone named J.F. Julius Schmidt at Athens Observatory in Greece in 1861 using their 6-inch refractor. And don't forget, this was first light for the 200-inch Hale telescope. I like to mention that. That's a good Jeopardy question. So I know it's a little small, but this is a personal favorite. So thanks for indulging me for checking this out. I know it's not one of the big flashy objects, but I love it. It's cool.
It is cool.
Any questions before we move on? We're doing real good here. We might even have time to take some requests later. Okay, so I'm going to close this. Oh, yes, go ahead.
There's a two of stars, it looks like. One's pointing at like 10 o'clock and one pointing at maybe 6:30. Are those just stars in a perfect line?
These are all, yeah, just random stars in the Milky Way galaxy.
Okay, thank you.
Yep. All right, so let me input our next target. This is a good one. So we're going to look at that nebula up close that we saw with the Takahashi earlier. So NGC 1977. Make sure I hit get coordinates. I often forget to do that. And yeah, we'll do a 5-minute exposure this time. I think that gives a good view. Again, I'm just going off experience, but I've done this before. And we'll let her fly. Make sure I hit the button right this time. There we go. Because one time I ran off and didn't do anything. Okay. So this is our next target, NGC 1977, the Running Man Nebula. It is 7th magnitude, which is going to be bright for the 20-inch. Don't worry there. It is pretty good size, 40 arc minutes by 25 arc minutes. So on the long axis there, it's bigger than the moon, and it's about 1,500 light years away. And it's part of Sharpless 279, which is an emission nebula that includes the reflection nebula known as the Running Man Nebula. It is the northernmost part of Orion's sword line, 0.6 degrees north of the Orion Nebula. So again, we're back in Orion there, but here's the close-up again with the chart. So the Running Man Nebula is right up here. In fact, I don't even see NGC 1977 labeled on the sky atlas here, so you can tell this area is a little crowded. So in a way, we're off the charts now. So this Sharpless 279 compromises 3 NGC nebulae. There's NGC 1973, NGC 1975, and 1977. Again, none of which are labeled there. And NGC 1977, the Running Man Nebula, was again discovered by, can you guess? William Herschel in 1786 using a 18.7-inch f13 speculum reflector. So that's very long focal length reflector. The nebula is easy to see in small telescopes, but the Running Man kind of dark lane is very difficult to pick out visually. So that's one of the great things about the remote sessions like this is we can often see objects that are either difficult or really impossible to see visually. So let's hop back and see how we're doing. We've already found a guide star. Ooh, we even picked up a double star. Hopefully it doesn't mess up. And let me pop back to the all sky camera. You can still see we have the zodiacal light. That can be very annoying from dark sky sites because it can get pretty bright. And so looks like Benno has turned off his red light. That's okay. That doesn't bother us too much. That's one of Mike Patton's neighbors there, and that was his red light. And the Milky Way is looking pretty good. Let's see what position the scope is in now. So as you can see, the Orion Nebula is pretty high. The quail is still in the building, so we can't close the roof yet. Not that we plan to. And you can see the flip flat for the Takahashi is now closed because obviously we're using the main telescope. You can see our club logo here. This is our flat field box, but this is a homemade one that hasn't worked out too well. We have a new one on order, but they're taking their sweet time getting it to us. All right, well, I'm gonna stop sharing here. And
can you elaborate on that flat field box and what that's used for?
Yeah,
this is the first time hearing it.
So to properly calibrate your images to make them as good as you can. You have to do bias frames, which is like the noise inherent to any camera. You can't escape bias noise, but there's always general noise from the heat of the camera. But of course, ours is to a minimum because it's electrically cooled. And then of course, your field is not usually evenly illuminated. And that's the case for the 20-inch because we had to move the position of the secondary mirror to be able to focus. So we have what's called vignetting with the images quite often, where the corners of the image appear darker than the rest of the picture. And also occasionally, dust gets on the mirror, or hopefully not the camera. And you can use flat field images to, number one, correct for the field curvature of the image to get a evenly illuminated image, to get rid of that vignetting, those dark corners. And you can also use a flat field to remove dust and other effects that might get on the mirror.
Okay, helpful. Thank you.
So we basically take an image of a bright white screen to create a flat field image and subtract that from the image.
Yeah, like you take your darks and you take your lights and stuff like that, and you stack them all together, and that gives a basis of a comparison. So the things that you are looking through on the CCD are probably like the inherent imperfections in the individual pixels, and those can be accounted for, and so they don't get into the mix. So great.
Basically.
Okay, thank you.
If anybody else had anything to add to that, you're certainly welcome to. No one knows everything, including me.
I don't have anything to add, but I have a question. I know that that this viewing is going on in Arizona. Does the Kalamazoo Club have a local observatory that you guys use?
We do. Give me a second here. I'll show it to you. So I'll just go from the page here. I'll go back. So next to the remote telescope, you can see one called Owl Observatory. Let me bring up the observatory part there. And there it is. It's another roll-off roof. This one's only 12 by 12. It's located at the Kalamazoo Nature Center. We installed this in 1998. And but just in September of 2019, we put in a new telescope in there, named after our founder, Leonard James Ashby. We have not even been able to show this to the public yet, even though it's been in there for over a year because, well, you know why. And so here it is. This is our basically brand new, hardly used telescope, at least hardly used by the public. So this is a 16-inch Schmidt-Cassegrain with a 4-inch teleview on top, and it's on an Astrophysics 1600 GTL German equatorial mount, which is fairly compatible or comparable to the Paramount that we have in Arizona.
Hi, this is Mohammed from Georgia. I have a question, please.
Yeah.
So you have been switching between telescopes to shoot different targets. There is criteria for selecting the best focal length for certain targets.
Yeah, so that's why it's good to know the field of views of the cameras. So obviously for that Rosette Nebula to capture the whole thing like that, you need that field of view, because the plane wave just shows you basically the cluster with some of the surrounding nebulosity. It really zooms in. And to get the entire sort of Orion can't be done with the plane wave, so that's why we have the Takahashi. So you have to know the angular diameter of the object you're imaging and the focal lengths of your telescopes or the field of view of your telescope with the camera to properly frame the target. But you could do a mosaic of images of like the Rosette Nebula with the 20-inch, take a series of images around it and paste them all together. So there are different techniques you can do. I think I heard our picture being done. I'm trying to find Firefox here. It's around here somewhere. Oh, that's right, where you have the Ashby telescope open. And let me go back to the, not that far. Again, I can't go to the tab because the Zoom stuff is in the way. So let me click there. There we go. Oh boy. Are you guys ready? Here we go.
Ooh.
So like the Orion Nebula, the Running Man is associated with Orion's giant molecular cloud. I'll talk more about that for the next target. The nebula is likely excited by 42 Orionis, which is a B1V type star in NGC 1977. Exactly which one that is, I'm not sure. But it's 4.6 magnitude and is about 3.8 arc minutes from the center. So it could be this one. I'm guessing that one because it's the bright one. And of course, it's part of a much larger nebula that is known as the Orion Molecular Cloud Complex. And of course, the complex extends throughout the constellation of Orion and includes the famous Barnard's Loop, our next target, the Horsehead Nebula, the Orion Nebula, M78, which is another emission nebula in Orion, and the Flame Nebula. So can you see the Running Man? To me, it looks like Gumby. Like this is supposed to be like his head. And there's like a leg here and a leg here.
Oh, yeah.
So there you go, the Running Man. He's like in stride, you know. And just beyond the image here, where you can just see a little bit, that's where the Orion Nebula is. But we're zoomed in on that specific region here. So later on, you can compare the Orion Nebula image or the Orion Sword image with this image and just see the difference and the resolution. Of course, you can see the difference in the field of view, but you can compare them later. Any other comments or questions about the image?
Yes, I have one. What is that darker area just above the center middle?
Oh, yes, right here?
No, down right there. Yeah, that.
Yeah, so this is a part of a dark nebula. So that basically is in front of the brighter reflection nebula.
Ah.
So this is an area where there's no starlight being reflected or no excited gas to give off its own light.
Okay, thanks.
So this is a reflection nebula, which means we have dust that's reflecting starlight. So quite often reflection nebulae, or usually always, have a very blue color, but the Running Man tends to look a little purplish to me, at least in some images. And so this is an area where starlight is neither being emitted or reflected. So that's what we refer to as a dark nebula. We're going to look at a very famous dark nebula next.
And may I ask one more very basic, that star that has the radiated, I'm going to call them direction pointers on it to the
Yes.
right. What optics cause that to happen?
I'll show you. Let me go to the scope. Oh shoot, you can't tell. You can't tell from this angle. Let me hit reload there. I don't know if that'll make a difference. I thought we could see it. You can just see it in this picture. You see the structure here. There, we have the primary mirror in the back and the secondary mirror here. There's like this cross structure that holds the secondary mirror called the spider vein. It's caused by that.
Okay.
You can't quite see it very well at that angle, but maybe we'll get a better angle a little bit later, but I don't think too well, at least for the next object. Okay, so we'll hop back to the browser. We can keep this up here for another second because we're doing pretty good on time. And if we had any more quick questions about the image, or
all of these objects are within the Milky Way galaxy, correct?
Yes, we are not doing any galaxies tonight. Once we get more into springtime, we'll be able to image more galaxies, but this is our last online viewing session, at least for the public. We might do some for members, especially if we can't view outside together because of the pandemic. But I should mention, by the way, online viewing sessions have nothing to do with the pandemic. This is what we had planned for quite some time. And so we will be back with these in November. But I'll have more about that later. Okay, let me input the next target. I don't know if I could do, well, I'm just going to type in the IC object to save time because this will work just fine. So IC 434, I'm going to hit get coordinates. We're going to do a 10-minute shot. We're going to switch to the H alpha filter and we're going to launch it away. Make sure I did hit the button. We are off and running. And I'll switch back to PowerPoint and give you a little intro here. All right, so our last pre-planned target is called B33, the Horsehead Nebula. So I'm sure you've all have heard of this at one time or another. So its magnitude looks pretty high, but that's probably actually for the nebula behind the Horsehead, which is IC 434. It's about 8 arc minutes by 6 arc minutes and 1,375 light years away. I'll refer back to 8 arc minutes and the distance later. And that is also located in the Orion Nebula, just below the first star, Alnitek, in Orion's belt. In fact, it's located about 30 arc minutes south of Alnitek, which is Zeta Orionis, the easternmost star of Orion's belt, or as you face it, the lower left star. The nebula was first recorded on a photographic plate in 1888 by Scottish astronomer Wilhelmina Fleming at Harvard College Observatory. So there's a bit of a story behind this. Edward Pickering claimed that his maid could do a better job than his, at the time, male assistants in identifying and cataloging observatory images. So he actually did it. He hired his maid, Wilhelmina Fleming, along with several other women who became known as his computers. And they're also known as Pickering's harem. So this is Edward Pickering over here, and standing is Wilhelmina Fleming, the lady that discovered the Horsehead Nebula. And so in addition to discovering the Horsehead, Fleming discovered 58 other gaseous nebulae, 10 novae, and more than 300 variable stars. She became the first American woman to be elected an honorary member of the Royal Astronomical Society of London. And photographing it in 1894, Edward Emerson Barnard, E.E. Barnard, described it as a dark mass, diameter 4 arc minutes on nebula strip extending south from Zeta Orionis. And it is really not known exactly who coined the term the Horsehead Nebula, but I can remember showing it to my niece when she was still very young, like 4 or 5 years old, and I asked her, what does this picture look like? And she's, like, horsey. So, it's pretty obvious why this is called the Horsehead Nebula. And you can see it hanging off Orion's belt here. People often turn the image 90 degrees counterclockwise when they display it in images, but it actually, the horse is kind of on the back of his head as we see it in the sky. I'm not sure how it's going to look in the view. I hope it's not upside down, but it might be. I can flip that over later. So you can see many of the other computers at work. Many became very famous astronomers in their day, not just Wilhelmina Fleming, but Annie Jump Cannon and several others. Let's check out the browser. I've heard it working away in my headset here. And we've already got that guide star. It's working pretty quick tonight, and we are on our way in our 10-minute shot. Let's hop back to the camera. No meteors, because I have terrible luck. So there we go. But a very dark-looking sky. Let's peek it on the telescope. Oh, I don't know if it's, I think it may have, sometimes the video still freezes, even though we're using the Edge browser. It should have moved a little bit. No, not too much. But you can see it's about as high as it gets. I mean, it's nearly level here. So should give us about as good of an image as you can get, given how high it is and how dark it is there. All right.
Is this the picture that had the quail in it before?
Yes.
And is it missing now?
I didn't notice. Let's go back. Edge.
Hey, Richard.
Oh, he removed the quail. The quail has left the building. So, yep, it is gone, which means we can close the roof now if we wanted to.
Can you see this this nebula
in a sober, or you have to really go to a dark sky?
No, of course, to see it in the summer, it would have to be late summer, right before dawn. So obviously, since the Horsehead is in the Orion or the constellation Orion, it is a wintertime object. I do want to mention that, visually, the Horsehead is really hard to see through a telescope because people often forget that it is a dark nebula, while the Emission Nebula behind it is fairly faint. Some member was saying last night he saw it in a 4.5-inch reflector. I don't know if he's here, but he might be on YouTube or he's here on Zoom.
I was foolish the other night. I tried to see it with my 6 inches. No way.
Yeah, I have seen it. I kind of saw it once before in our observatory here in town, Owl Observatory. We used to have a 12-inch Schmidt-Cassegrain, and one night, very cold night, we were following the Emission Nebula behind the Horsehead, and then it stopped and started again. So that's where the Orion or the Horsehead Nebula should be, but we couldn't see the shape. But then, back in 2005, I went down to the Florida Keys for the Winter Star Party, and there's this guy that was often there. I don't know if he still is. He was known as Crazy Bob Summerfield, and he has the famous Yard Scope, which is a Dobsonian with a 36-inch primary mirror, so much bigger than our 20-inch, obviously. And he had this long line of beginners looking at the Horsehead Nebula, and he had to explain to each person how to see it, how to find it. And finally I walk up, look in the eyepiece, I'm like, oh, there it is. And he's like, oh, thank God, because that's one thing we have to do as amateur astronomers that share our views, is we often have to explain these things over and over again. So it was clear as day in a 36-inch Dob from the Florida Keys. That was awesome. So that is the only time I clearly saw the Horsehead with that eyeball right there.
That's great.
Any other questions or comments? Can be about the KAS, the club itself, the telescope, crappy weather in Michigan.
What's your favorite pair of binoculars for the 200 power range?
They don't make binoculars.
200 power, but the big guys.
Yeah, 20 by 80s are really good. They're big, but not too big. I've used some 20 by 80s that I used to have at the school that I taught at. The club has some, oh gosh, what size are those? The roughly 20 by 100s that we have available for loan. Those are very nice binoculars that we just bought a parallelogram mount for. I've never looked through anything much higher than 20 power myself. But I know there are bigger versions out there, like the binocular telescope that Yuji Hyakutake used to discover Comet Hyakutake back in 1996. That was a really big pair of Fujinon binoculars. Somebody asked, I just saw the chat pop up, does the KAS telescope have a camera? Of course, as I mentioned, the remote telescope does, obviously. So both the 20-inch and the Takahashi use the same camera, which is that STX 16803 CCD camera. We do have a camera in Owl Observatory, but so far I'm the only one to use it. We haven't really got up to speed yet with the Owl with the Leonard James Ashby telescope in Owl Observatory because of the stupid pandemic. We've done some training, but it's hard to do that stuff together when you all got to wear masks and stuff like that. We've discovered observing with masks on is very difficult because as soon as you look in the eyepiece and breathe a little bit, the eyepiece fogs right up on you. So that's no fun. We should check in here, see how we're doing. Let me peek at the observatory computer. Our guide star looks pretty good, nice and steady. And we're a little more than halfway there, so we're getting there. We'll definitely have time to do some requests. We are currently, of course, running the 20-inch, so if we did have anything that required the Takahashi, we'd have to take the time to switch, so we may just stick with the 20-inch. I know most people prefer the 20-inch anyway. And look at that. The wind is at 7.8 miles per hour. That's a bit heftier than predicted, but not too bad. The Guy Star doesn't look like it's hopping around very much, but once we tend to get up to toward 9 miles per hour, it can get a little shaky out, but not too bad.
How many members do you have?
I'll give you the numbers from the end of last year. Right now it's in flux because we're still waiting for some people to renew. We did pick up several today after the lecture series today, which is great. But at the end of last year, we had a record 191 paid memberships, which was, again, an all-time record for us. And if you count the family memberships as 2, maybe plus throw in a few for the kids, we probably have close to 300 individual people in the Kalamazoo Astronomical Society. There's a pretty good chance we are the largest club in Michigan, which includes the clubs over in the Detroit area. I know we're bigger than them for sure. I'm not quite sure about the Grand Rapids Club. They're not so transparent with their information compared to us, but we're pretty close to the Grand Rapids Club in terms of membership. But per capita, when you compare the populations of Kalamazoo and Grand Rapids, we're much bigger than they are.
Richard, on the chart we were looking at a minute ago, it had ambient temperature and sky ambient temperature. What's the difference?
I don't know. I don't know that one. I'd have to think about it. Off the top of my head, I don't know. Is it possible to find the ISS with this telescope only by accident, not by planning? It's not equipped to track the ISS, so if we do happen to have it pointing at the right place at the right time, it would be a very bright streak going through the field of view. So that could certainly happen. Hasn't happened yet. We get plenty of regular satellites. As I was joking last night, we're still waiting for the Jewish space laser to go by. We haven't seen that yet.
The ISS has its own tracking software. If somebody was really interested in seeing where it is, it's got its own tracking software, and it'll even tell you when it's within 5 minutes of sunrise or sunset, so that you can log in and see the camera. So whoever asked that question.
Okay, great. Yeah, there is definitely specialized software you can use to keep your telescope up with it. I've never tried it myself, though.
To answer the question about the sky ambient temperature, they're measuring the temperature of the clouds to determine if there are any clouds up there.
Okay.
Versus ambient.
Oh, I heard some beepy beepy going on, so I think we're there. Let me go back to the browser if I can figure out which one it is. Good Lord, I got a lot of windows open. Holy moly! And again, I can't get to the tab because the Zoom stuff is in the way. Oh, I see it. There he is. Horsey.
Oh, wow.
We could have did a longer exposure, but that's pretty good.
Oh my gosh.
And I should mention one thing, because of the on-axis guider, the images are inverted. But when I process them and make them available for download, I am going to flip them for you. Wow. So you'll be able to see the horse head the way it was intended, so to speak.
Cool.
So obviously the horse head is a dark nebula. So again, it doesn't emit light or reflect light. It is just dark. And I did some math earlier because I didn't see any references to this, but I used its 8 arc minute long axis here and its distance of 1,375 light years, and did a little trigonometry, making use of that math minor. And it's about 3.2 light years tall, like this way. So from the top of his head to down here, it's about 3.2 light years. And again, it is part of the much larger Orion molecular cloud complex, which is actually composed of 2 giant molecular clouds. There's Orion A and Orion B. The horse head is a part of Orion B. And if you look for infrared images of the constellation Orion, it is filled with dark clouds. Not just the bright stuff that we can see in like the horse head or the Orion Nebula and so on. So the background nebula, that makes it possible to see the Horsehead is IC 434, discovered on February 1st, 1786 by, again, William Herschel, and illuminated by Cygni Orionis, which is just below Alnitak, that first star in Orion's belt.
And that's an emission nebula behind it, is that right?
Yes, it's an emission nebula. It doesn't come out here in H alpha too much, but right here is the emission reflection nebula NGC 2023, again located to the Horsehead's lower left, about 15 arc minutes to the northeast. Again discovered by William Herschel on January 6, 1785. It is illuminated by HD 37903, which is a B2 main sequence star, a star larger and hotter than the sun. So it is this star that causes this nebulosity here, but again, it doesn't come out in H alpha too well. And just outside the field of view, down over to the lower left somewhere, is NGC 2024, the famous Flame Nebula that you may have seen in other images of the Orion Nebula. So there are your images for the night.
Beautiful. Thank you.
It is beautiful. And if you're taking requests, we could go to the Flame Nebula next, right?
Yeah, we could do that.
Oh.
So I know
we did have a request for M41 as well.
Oh.
Okay. Let's do the Flame Nebula because it's so close, and then we'll do that next thing. You'll have to remind me what it is already. It's going in one ear and out the other, even though I got headphones on.
Can I ask, are the stars that you see in the dark nebula, are they foreground stars, or are they stars that are shining through the dark nebula?
Yeah, these would be foreground stars. Yes, you can see a little bit of noise here. I think this is all noise, but the larger, brighter points are stars.
What is the difference in the image using this filter as opposed to a plain filter?
If we had time, we could do an image with the luminous filter, but you know, the H alpha brings out the nebulosity a bit more, and again, it tones down the stars because right outside the field of view is Alnitak in Orion's belt, and that usually causes a bit of glare in the image. But if we have time, we could do a shot with the luminance filter too. So let's we'll go ahead and close this, and let's see. The Flame Nebula was NGC 2024, I think I said. Again, it's going in one ear and out the other tonight. It's been a long day. Yep. Okay, so let's try that with we'll try 5 minutes with the luminance filter and see how that does. All right, we're off and running there. Oh, let me I kept forgetting to do this tonight. Let's go back to Edge here. And of course, it's not going to go very far. Yeah, so that's kind of a dumb idea because it's barely going to move, and I think it may have froze anyway. But I think it did move a little bit. There it goes. Oh, actually, it's going to flip because it's so close to the meridian. It's going to do a meridian flip and slew to the other side of the mount, so you can see the scope go all the way around. There's the infrared light from our webcam. When I am imaging, I often turn that off. I don't think it'll cause any interference, especially with the plane wave, because the cold mirror does not let infrared light into the camera. I feel like I should add some sound effects here.
I know that you're looking at nebula, but if you get a chance, will you swing past Alberio?
That is below the horizon. That's a summertime object, so we couldn't do that one tonight if we wanted to. Yeah.
Orion.
So we'd have to try to do that in like November for one of our first sessions.
Right.
But
sorry,
Alberio wouldn't quite be the same because, you know, you can't see it in color. And I know it looks like it, but at no point does it ever hit the wall there. But if we got a 24-inch with the Takahashi, we would have been in trouble. So this is as big a scope as we can put in this spot, unless we put it on maybe a different mount, like a fork mount or something. Then it might work. I don't know. All right, we're there. So let's go ahead and let it work for a while. Got a lot of chat to look at. My goodness. Someone asked, is there any benefit of using the spotting scope versus binoculars? You often see the image better with binoculars because our eyes are used to working together. I forget the exact figure off the top of my head, but the image appears to, it at least appears to be brighter when viewing with both eyes. So like a pair of 20 by 80 binoculars would always be better than a 80 millimeter refractor with a 20 power in it. But of course, with a spotting scope, you can get a more range of magnifications compared to a pair of binoculars. Is it possible to see the Cepheid variable stars? Well, we can image them, but they're not going to vary in front of you. I'm not sure we can do M31 now. I'd have to go back and look at the all-sky camera to see how low it's getting. We can do it with the plane wave, but we would only see the center of the galaxy. Looks much better in the Takahashi. Did someone have a question?
I was going to say there's some chat in there about different kinds of nebula. Maybe you could give us an overview quickly.
Okay. Of course, you know this. Why don't you do it? So there are three types of nebulae, at least involved in star formation. There's emission nebulae, like the Orion Nebula. So if you have very hot stars that give off UV light, it excites the gases around it and causes them to glow. So that's what we call an emission nebulae. And quite often, emission nebulae, like the Orion Nebula again, is where you find active star formation. That's why we call the Orion Nebula a stellar nursery. And then I mentioned reflection nebulae earlier. That's where you have small dust particles that scatter blue light, because the particles are so small they can only reflect blue light. So that's why reflection nebulae look blue. And then dark nebula do none of the above. They don't emit light, they don't reflect light, they're just dark. That's why we call them dark nebulae. There are also planetary nebulae, and those are all basically from dead or dying medium mass stars like the sun, or a little bit bigger. And then there's supernova remnants, which are stars that blew up.
And how would we recognize a planetary nebulae?
They often look like planets at low magnifications. So they usually have a very distinct spherical shape to them. Even the Ring Nebula is kind of spherical, and at low power, it does look like a little blue disk. Try to let somebody in there. Someone mentioned the Witch Head Nebula. I almost decided to do the Witch Head instead of the double cluster, but I figured I did enough nebulae tonight, so I should throw in one cluster in there. The Witch Head is faint, but we can see it with the Takahashi with a long exposure. It's pretty big for the plane wave. Okay, so we'll do M41 next. Let's. I haven't heard any noises in my headset here, so let's see. Oh shoot! Because of the wait flip, we have to wait 168 seconds for it to complete the flip. So let's stop that. Oh, ow. And of course that's very loud and hurts my ears. Oh shoot! I wish I would have waited for that. So we did lose some time there. Now let's go back and do M41 because it takes a while for it to complete the flip, and let's see if M41's in a better position, and we'll try that instead. We'll knock it down to 180 seconds here. I probably should have left the web browser on, but it's nice to see all you people here with us tonight. We are very glad you could join us. And I again want to say hi to everyone on YouTube. As I always like to mention, there's a 20-second delay between YouTube and, oh, it looks like the YouTube stream started. They must give you a time limit for how long you can stream because it stopped. Huh. Well, that's interesting. I hope they got to see at least the Horsehead Nebula. Does anyone know about that? How long do you get live streams on YouTube? Because I did not stop it. Okay, we're moving the telescope. Let's watch the telescope move. That's always fun. Oh, now she has to go back all the way around. Ah, it froze. That's not where M41 is. We do have just DSL out at the observatory in Arizona Sky Village, so it's 20 megabits per second if we're lucky. So sometimes the webcam does freeze, especially when we're uploading images from the telescope to the to our cloud, to the cloud. Now you can see the spider veins that cause the spikes on those stars. So that is what makes spiky stars in astrophotos. You can't add those artificially, but they're never the same as the real thing.
Hey, Richard, when you want to have color, you take like 3 exposures, or?
Well, you do luminance for the resolution, because that gives you the sharpness of the image. But then to get the color, you take images through red, green, blue filters to get a natural color image.
And then you have to use some software to put it all together, or how's it?
Yeah, a lot of us use like PixInsight. That's a really hot imaging program these days. It's very hard to learn, though.
Yeah, it sounds like a lot of work.
It is. It's a lot of. I will talk about astrophotography in part 5 of the lecture series we're doing right now. We had the second installment today, and one of the things I often kind of tell people to do is not to do this because it's addictive, it's expensive, and it is hard. It's a lot easier than it used to be, but it's still hard in some ways. Because back in the old film days, there are days I loaded film in the camera. I thought I took like 20 images, but the film tore on the spool and you didn't get anything. You didn't know that until you open up the camera later. All right, so we slewed. It's found a guide star, and it's going to start taking the picture here. We don't necessarily have to stop right at 11 either, 11 Eastern time. We can keep on going, so we definitely can double back to the Flame Nebula and maybe try 1 or 2 more targets. I'm willing to go for a bit longer if you guys are. I was hoping to finish my imaging routine of the Orion Nebula, but that's okay. I could wait. Because my red filtered shots did not turn out as well as I wanted to. It got a little hazy one night. All right, so we can escape the sharing there and go back to seeing everybody. Yeah, Lloyd.
Would you mind sharing the link for the download for tomorrow? Some people are asking about it in the chat.
Oh my goodness, I forgot all about that. I'm sorry. So yeah, let me finish with the closing stuff here, since we still technically have 5 minutes. If you do live in one of these red counties in Southwest Michigan, you can join the Kalamazoo Astronomical Society and use the remote telescope. It is a additional $50 fee that helps us pay for software, subscription renewals, and upgrades for equipment and maintenance and all that sort of thing. We do not currently let anyone outside this area use the telescope. Use amongst roughly a half dozen of us has been enough to keep it pretty busy. But of course, as more people start using the telescope, that'll kind of eat up into our time as well. And this is our last session. But if you would like to be notified about next season, probably around October, I will send out an email to the online viewing session email list. So if you do this, you can receive reminders about sessions, registration, and YouTube links, which you definitely needed the YouTube link tonight. again, the link to download the images, which I'll give you here to you shortly, and notifications of postponement or cancellations. You can use our contact form on the website. There's a specific part of one of the drop-down menus to say to be added to the online viewing session email list, or you can just email us here and say, hey, Richard, I'd like to be added to the online viewing session email list, and you can join us next season. A quick plug for our next general meeting. We just had one on Friday, so our next meeting will not be until Friday, March 5th at 7 o'clock. We got another great guest speaker via Zoom. Dr. Pascal Lee from the SETI Institute will present in approximately equal to 1, Alone in the Milky Way. So that's he's going to kind of speculate on the rarity of extraterrestrial life beyond Earth.
Hey, Richard.
And yes.
Yeah, we're not seeing the screen.
Oh, shoot. I forgot. That was the first time I think tonight I forgot to share the screen right. Okay. Let me back up here. Okay, so if you live here, you can use the telescope for an extra fee. There's the online viewing list, so there's our email address. But again, you can use the contact form on our website. And so here's the preview for our next meeting. There's more information on the website. And I don't know if it's going to happen, but the schedule for the 2021 public observing sessions at the Kalamazoo Nature Center is now on the website. If you scroll through our schedule page, you can find it on there. If you go to the public observing session page itself, you can find the schedule there. And we are hoping we can share our new telescope with the public. And now I'll leave this here for a second. The image is now done, but I'll leave this here shortly. So here is a link to download tonight's images. Obviously, you can't go there now, but I don't know if I'm going to have it ready tonight, because after the lecture today and this, I am spent. So after this is done, no more astronomy for me for one day. I'm going to veg out, and so I probably won't get these until Sunday afternoon. But just keep checking, and they'll be there. So this is the link to download all the images we take tonight, even the bonus images that we're doing now. If somebody wants, you can put that into the chat, so it's easier to just copy it and save it somewhere. Or, I don't know, click on it, bookmark it, and just keep checking back until it's active. And I will keep images from tonight at this link for the next few months at least. But eventually I will remove them, but it won't be for several months, because I'm very conservative when it comes to the space that we have available on the website, even though we have plenty of it, but I'm still very, very strict about stuff like that. I can't help it. Okay, so let's go back to the browser. I'll do it properly this time. I can bring the link back later. And,
we got the link in the chat, Richard.
Oh, thank you. And I can't go back to the proper tab now because of the stupid Zoom thing. There we go. So M41 is an open cluster. So voila, pretty cluster. So thank you, whoever requested the image of M41. If memory serves, it is in Canis Major. If anyone knows anything else about it, you're welcome to share your information. I have no idea how far away it is. No notes for this one. In fact, we haven't done this one for online viewing session yet. Okay, so let's go ahead and do the Flame Nebula. We should be far enough past the meridian to do that one now. And again, let's do 5 minutes. We'll see how that does. Make sure we're good there. We're good. Let's see if we can watch the telescope slew. And you can see the brightness on the walls from the infrared. Oh, there it goes. Well, I hit it now. Too late. That's from the infrared light from the webcam. It might cause issues with the Takahashi, but it shouldn't with the plane wave, if I'm correct. But often I tend to turn it off. We do have another camera we can use that we can turn the camera on and off. So there we go, slewing away. Oh, I got to hit play. Well, it looks like it's doesn't look like it's working. I'm talking about the YouTube linking.
I just checked on it a minute ago and it was still going.
Maybe I got to hit reload. Oh, there we go. Now I can see it. I can see me looking at it, trying to figure out why it wasn't working. That was okay. So I had to hit reload to get it to go stream again. That's weird. Why would it stop on me like that? So we still got 30 on YouTube. Wow, that's amazing. Oh, looks like we finished slewing. We'll just go ahead and let it work. It's gonna do the guide star. Or what it does first, though, is when it gets in the general area, it takes a test image, and then it does plate solving. It matches stars in a database with the image, and it precisely centers the image. So you'll notice even with something tiny like Hubble's Variable Nebula, it put it right in the center. I got to turn my heater off here. It's getting hot in here. Okay, so is that M41? That's 2,316 light years away, but that's pretty far away for such a large cluster. I'm guessing the Flame Nebula is again about 1,350 light years, since it's all part of the Orion molecular cloud. I see people yawning. Remember, that's contagious. It's going to spread. Okay, I'm fine. Is this the last image? I don't know. I'm willing to keep going if you guys are. I mean, we currently have 86 on Zoom. That's more than we've had for all the sessions this season. I think we maxed out around 70, 75 for the first couple.
Yeah, this is much better than freezing outside.
It sure is. So, of course, you're welcome to leave anytime, but we're going to keep going. Oh, I'll let Don in. We do
I have a question here, if you don't mind. So,
oh, please.
What if something wrong happened, like cable got stuck, or how would you fix this remotely?
Well, that's a long story with the cables. We spent a lot of time securing the cables, but so far we have not had issues parking the telescope. It's always parked, but sometimes the roof doesn't roll off, and we receive an automatic email when that happens. And we tell people that use the telescope, if it's going to possibly rain the next day, to call us at 4, 5 o'clock in the morning if they have to, and tell us you have to close the roof. And so we can do that by controlling the computer out there remotely. And so far we haven't had an issue yet. But usually if it's going to be clear at night and we're observing, it's not going to really rain there the next day. It hasn't happened yet, but so far we haven't had any serious issues like that, thank goodness.
So there is any something like remote hands, somebody's out there that can help physically help you?
There are, yeah. If Mike Patton's not there, the guy that owns the observatory and lives at a house very close by, there's another gentleman named Rick Benno that's agreed to help us. And there's one more year-round resident that you might have heard of, Fred Espinac, Mr. Eclipse. He lives at Arizona Sky Village, and he's agreed to help us from time to time if we get in trouble. So we can always call them and say we can't close the roof either, remotely from our end. So could you please go out there and close it for us sometime? And they would, But what they might do, what Rick might do, is unplug everything until we can diagnostic. So because he's not going to go out there night after night after night when we can't close the roof. So so we'd have to check it out.
So I have seen in one of the telescopes that you have the secondary mirrors covered by a piece of cloth, which is the cover. I understand that. How do you remotely remove that?
It's not on when we use the telescope remotely. So usually the optics are uncovered. So like if you saw a picture on the website with the secondary cover on, that's just during the day. So there's no chance of pointing it at the sun the wrong way and we burn a hole in our camera.
No, what I mean is so nobody's there. So you constantly keeping it exposed for the lenses. Okay.
Yeah, it's amazing. We haven't had any dust issues on the primary or secondary mirror, keeping them uncovered all the time. You might think, but because of it's basically horizontal in the park position, so dust really can't settle on it.
Yeah.
We've had issues with moth poop. That's a big problem out there.
With what?
Moth poop. Every few years they get like a major infestation of hundreds of thousands of moths. Oh. And they just recently cleaned moth poop off the mirror. Isn't that exciting?
I'm assuming you use like a high-speed internet connection, like you connect to those telescopes. I mean,
yeah, no, not high speed. As I mentioned, we have a DSL connection out there.
Oh, DSL.
So it is not fast. Yeah, it's pretty remote. We're still hoping to get high-speed access. That'll change a lot of what we can do. We'll be able to upload images a lot faster and stuff like that, but we'll be able to do a lot better streaming. But really, it's pretty usable. It still takes about 2-3 minutes to upload each image from there to our cloud account.
And those images are pretty heavy, so
yeah, they're each about 32 megs. It's only a like 17 megapixel camera. So compared to some cameras today, they're not super huge. I should probably write down our bonus objects so I remember what to download later. So M41, NGC 2024. Otherwise I will forget. And there's a lot of images in the cloud now, so it'd be hard to track them down. All right, we're almost there. Tick tock, tick tock.
Yeah, I was the one who suggested M41 because that's the one I was able to see from my backyard.
Oh, tonight, right now?
I saw it like 2 days ago, and
okay,
you can actually see it with like binoculars. Like you don't need it's pretty bright.
Yeah,
and even in polluted skies. So I mean that's the stuff that I'm able to see. I cannot see any nebula except for the M42 Orion. But I live in the city, so it's like.
And where do you live?
I live outside Atlanta, so.
Oh, okay.
It's pretty bad. I mean, you have to drive like 2 hours probably to get decent skies, and with the COVID, we haven't been able to go out too much. So.
I've been to your zoo and aquarium. That was fun.
Yeah, it's nice.
Oh, there we go. Oh boy, you can see out in the tech. Holy cow. Let's give it a second there. Bonk. There's one.
Which one is this?
This is the Flame Nebula.
Oh,
I only heard one bonk. That's weird. Usually hear two. Whoa. So you can see why we do H alpha. It tones down those stars. That is bright.
Ooh, oh my gosh.
Beautiful.
That is beautiful.
Definitely.
Wow.
Hi, will the pictures that you publish have titles or names on them?
They will. It'll have lots of information. It'll have the designation of the object, like this one will say NGC 2024. It'll have the scope used, the exposure, the filter, I think even the temperature of the camera, but it's always minus 20. So I'm not sure why we even put the temperature of the camera in there because it's always minus 20. But yeah, there'll also be a text file that has the key for how to decipher the image file name.
Wow, thanks.
Yep. So it'll say a lot more than just NGC 2024 because everyone will email me, how long was that exposure? What telescope did we use? So that'll all be in the file name.
The minus 20 degrees on the camera, is that ever less than minus 20?
No, we've never gone lower than minus 20. It's all preset, so it's set to automatically go to minus 20. Technically, the camera can go to minus 50, but we've never done that. We could never do that here in Michigan. The camera would fog up really so fast, and it'd never clear because it's so humid. But out there, it's very, very dry. In fact, let's see what the humidity is tonight. But let's gawk at the image a little bit longer. So yeah, this is very close to the Rosette Nebula. Who knows? Maybe you can even combine the two images together. I don't think they quite overlap much, but pretty close though. All right. Any other requests? Oops. No.
M46, if possible.
Okay. I should have. Let me go back there. Ooh, the Flame Nebula. Okay. M. Is that an open cluster? I don't know that one off the top of my head.
It's the one we were talking about last night. It's got the planetary inside of it.
Okay. Let's try.
It's in Puppis.
What do you think? 5 minutes? I'm trying to think of something good. 5 minutes is probably good. Let's go ahead and try that.
Yeah, that should be cool.
Puppis. Let's see how the sky's doing. Holy cow. Mike, turn your light off. Look at that. It's called a dark sky village, Mike. You can send hate mail to mpatton at, no, never mind. Oh, that's awful.
So I have a question. Like when I'm looking at, right now, I just put an M46. It says apparent magnitude 6.33. Is that, what's the difference between apparent and then the actual magnitude? I mean, I get
yeah,
confused.
there's another version of that. Apparent magnitude is just how bright it appears in the skies above Earth. So it doesn't account for, its distance or temperature or size. There's another scale for stars called absolute magnitude. And so the absolute magnitude of a star is the apparent magnitude it would have if it were 10 parsecs away. So some examples are the apparent magnitude of the sun, or the absolute magnitude of the sun from 10 parsecs away is actually 5, about the same magnitude as the dim stars in Ursa Minor.
So apparent is good to use when trying to see if the object is gonna be faint or.
Yeah. So if you're looking for a cluster that's 12th magnitude, that's the apparent magnitude. If it has if an object has an absolute magnitude of -5, something much brighter than the sun, it of course it won't look -5 in the sky, which would be about the brightness of Venus.
Right. Okay. Makes sense.
Yep. So absolute magnitude is a better way to figure out the true energy the star is given off. Apparent magnitude, again, doesn't tell you anything like that. Okay. Oop, I can't go back to the right tab again. I wish there was a way to get the zoom stuff out of the way. But we're doing good there. We're pointing. I'm gonna.
Can you quickly show a star map as to where you're looking at right now?
Let's see if I can open up Starry Night. I can do that. I got Starry Night installed on the computer. I think I got enough memory so all the windows I have open doesn't crash the computer. So this will take a second to start up. It's a big program. Tens of thousands of stars to load after all.
You had a strip map that showed us where you were going for the double clusters and things like that before.
Yeah, we're doing objects off the script now, so I don't have anything preset this time.
Uh-huh.
We're doing the bonus objects now.
Can you just use the clear sky chart on the page that shows what the telescopes are doing?
The clear sky chart, that's just for seeing the weather conditions.
Oh, okay.
You mean the sky and telescope? Probably.
Yeah, I think we're off the charts I have scanned.
You'd have to put a real chart in front of your face and put your finger on it.
Yes, I'm having trouble here. It's being very temperamental. There we go.
Yeah.
Let me turn on the, well, we'll let the image go. So I got time here. Got to turn on the lines and go to, I'll just have it search for M46. The Zoom stupid thing's in the way. There we go. Okay, I got to share my screen now. Let's see, where's Starry Night? There it is. Okay, so this is Sirius and Canis Major, but here's Monoceros, but I thought you said it was in Puppis. So the border of Puppis must be extend up here. So M46 is above Canis Major and kind of above him to the left there and above Puppis, which is kind of an obscure constellation for us in Kalamazoo. Oh, this is set for Kalamazoo too. I could switch it to Arizona Sky Village, but won't bother. It's the same sky, just things are in a bit different position. So that's where we're looking. About due south, so the telescope should be pointed nearly horizontal. Let's see. Yep. And how's our image doing? I see it working there. We're a little more than halfway through. You can see the guiding's a bit more choppy because we are looking fairly low. So the scene, the atmospheric stability is a little worse. Unfortunately, I can't hear you.
Sure. So I had another question on like Mars. Right now, you can see a lot. What filter should we use for like planets? Like, the color filters are, I don't know. I feel like it makes it hard to see the detail.
Yeah, of course, Mars is way past its prime now. It was in opposition back in October. So it is getting dimmer and further away now. But there is a great filter I can recommend. Orion Telescope and Binoculars has what's called a Mars filter. And that is fabulous. I bought it for the 2018 opposition, but really never got to use it because of the dust storm, because it's not going to do anything for a dust storm. But I did get to use it during this opposition. It really helps out, bring out detail, and doesn't make it funny colors like red or blue filters do. So the Orion Mars filter, it kind of combines the best of many filters and really enhances detail on the surface and allows you to see the polar cap better and so on. And it's only like $40, $45. So I would highly recommend a Mars filter for when Mars comes back. Of course, it's still pretty decent, but it is getting smaller and harder to view details. But yeah, Mars filter is great.
Yeah, I'm looking at it. It's $40, pretty good. Thank you.
Yep. If you go to our website, the kasonline.org, click on Sky Shop and go to Orion Telescopes and Binoculars. And then if you buy the filter, we get a commission.
Good to know. It's about a bunch of stuff already. That's good.
And buy it with Amazon Smile.
Yeah, there's that too. I keep forgetting to do something with that. All right, now we gotta wait for it to stop here. I don't know. There we go. So we've got to look for a planetary nebula in the cluster. I've had these headphones on too much today. Ow. Oh, there we go. All right, give it a second to load. This is just a thumbnail. The actual picture still has to go to be loaded. Bonk, bonk. There we go. Oh, there it is. Oh, that's cool.
Wow. That is cool.
So obviously this is the planetary nebula, the dead sun-like star, probably a little more massive than the sun though. Now, does anyone know, is there a debate if this is actually in the cluster or is it a foreground object? Kevin, do you know? Since this was your pick.
I'm looking it up. I can't remember.
Okay. I like the, looks like a linear dark nebula here. Can you see that? I don't think that's an artifact. That's like a dark nebula there.
Looks like
I think the nebula is in a different focal plane.
Okay.
Than the cluster. I don't remember which direction, whether it's forward or backwards, but I think it's a different focal plane.
And what was the number on this one again?
This is M46.
Do you think that the cluster extends beyond the field of view?
I don't think so. I'm not sure. I can probably, let me just hop back to Starry Night without switching screens. I can give you the angular diameter of this object. Let me,
Richard, I've got that. It's
20 arc minutes. I got it. So
okay.
yeah, the whole thing should be in there easy. Because our field of view is 36 arc minutes square. It looks bigger than that though.
The planetary nebula is NGC 2438, and it's just superimposed.
Okay.
Could you say that number again?
NGC November Golf Charlie 2438.
I feel like we're coming in for a landing. Wave them off, Kevin. Don't land. So I said the cluster is probably around here.
Yeah, that's what it looks like.
There could be some outliers over here.
Yeah, that bright star looks like a candidate.
Yeah. More dark nebulosity over here too.
Yeah, there's in a wider field view that I'm looking at on Wikipedia, it's a little bit bigger than what we have in the field here. If we shot it with the TOC, it would probably, it'll give you everything. I know it takes too long to switch the scopes, but
it doesn't take that long. We could switch, but I don't want to keep switching back and forth.
Yeah.
That line you see, there's like a black line that you see. Is that, what is that? Is that dark?
That's
nebula?
probably dark nebula. Wow. Just basically dust and the plane of the galaxy. Oh, I heard myself echo. All right. Any other requests?
Would you do M1?
Yeah, we could do that.
You make it look like a crab?
I'll try. Let's just do, I'm going to try 60 seconds because it's easy to overexpose that. And let's see what we can do.
Cool. Thank you.
We're feeling kind of crabby now, I take it.
That's another one I can't locate in my area.
Yeah, it's.
I only see it.
It should be in a good position because it's very high now, I think.
Yeah, it's oh, let me get rid of this. It's right there.
Yeah.
Oh. Yeah. Well,
it is very dim. It is
Yeah.
very dim visually, so it is kind of hard to pick up.
Yeah, I have not been able to. Like, I
Did it
follow
freeze
all the
again?
instructions and everything, and I still don't see anything.
Yeah, you have to use averted vision and have good eyesight, good dark sky.
Yep. Appreciate the tips. Hopefully one day I can see it. I have to go to dark sky, definitely.
Yeah.
There is so much snow on the ground right now. We won't hit dark skies until April.
Yeah, it took a while, but February finally brought winter to Michigan. I had the plow shovel snow yesterday. I was not a happy camper. I probably could have done it today, but I've been too busy.
We got a little snow in Indianapolis too, but not much.
Okay. You ever been to the Indy 500?
Yeah.
You probably can't live in Indianapolis and not go to the Indy 500, right? I've never done that. That's kind of a bucket list thing.
It's fun once.
Yeah. Yeah, it gets a little tired seeing cars go in circles for a few hours.
We have no snow in Port St. Lucie.
Oh, shut up, Dick.
Yeah, but you have much higher humidity than we do right now.
Yep.
Could be.
We're between 1 foot and 2 here.
Yeah, it's well past my knees. We've had snowplow out 4 times since last Sunday.
I only had to shovel twice, so we aren't anywhere close to that much snow down here.
Yeah, we're getting more on Thursday.
Do you think we can see the Eskimo Nebula? Is that still available? Or?
But we could try that, yeah.
Wow.
It will look tiny on the image we have here.
While we're waiting for this image, can I plug an upcoming event or no?
Sure, no, please go ahead.
So the Indiana Astronomical Society has our regular general meeting coming up on Saturday the 20th at 7 p.m. Eastern time. And
Okay.
Our guest speaker is going to be Norman Fulham, and he's going to be talking about making telescopes, and he's a optician or how do you say it? My brain. Optician and telescope maker. And so anyway, he's going to be speaking. Just thought I'd throw that out there for anybody who's interested.
Yeah, if you throw a link into the chat and we can look for more information.
Okay.
That'd be great. Thank you.
You know, since I know your next meeting's not till the 5th, this gives more stuff to do while we're all stuck inside.
Yep. The only thing we have going on the 20th is the third part of our lecture series, but that's at 1 o'clock in the afternoon. So we got plenty of time to get ready.
I'll be there for that as well.
Oh, great. I will mention
All going to be heady with the excitement of the Mars Perseverance landing 2 days.
Yeah, that's
earlier.
right. Woo-hoo. Oh, got a little glow on that one. Okay, give it a second.
Is there a bright light in the neighbor's house?
That could be. Probably shouldn't look too bad here. It's a little. There we go. That's not too bad.
Oh yeah, the Crabby Nebula.
I'm not sure what exactly is giving us this little glow here. I don't know if we did get light interference or something, but
See which way the telescope's pointed.
yeah, let's see.
Yeah, is that light still on?
The infrared light. I think Mike's porch light is out. We shouldn't be getting any issues with the infrared light.
Shouldn't be.
Unless I don't think it's hazy overhead.
Kinda
I have no idea. Maybe it's the short exposure. I have no clue. Oops, let's go back. We didn't get to look at that very long, so let's bring that back up. So there's the claws and the body right there. Okay, that's the crab.
Where are the claws?
Right there. Can't you see them?
You have to zoom, I think.
It's not a king crab. It's one of the other ones that they hunt, that they fish for up in Alaska.
Oh, now I get it.
Opelio, yeah.
Yeah, it's OP season right now.
It was
Just
Lord.
looks like a supernova to me.
Yeah.
Did you have an all sky telescope still available to look at the sky, right? Is there any haze in the sky?
Well, that light is back on. That could have been
I think
it.
that's what it was.
All right, I'm again, send hate mail to Patton. Never mind. Don, email Patton and tell him to turn his effing light off. It's called the Dark Sky Village.
Hey, our telescope is on his property. I'd watch it.
Yeah, he wouldn't mind. He probably thinks we're done now, though. So
Yeah.
of course, he sees the roof off. That's a telltale sign we're still using the telescope. All
Yeah,
right.
he's not on here
Thank you.
anymore.
That was nice.
Okay, yeah. So Mike's gone in. That's why the little quail is gone. Hopefully, you can zoom in and see some of the tendrils later.
Yeah, they're there.
Yeah.
Since we're on nebulae, how about M78?
Oh, okay. Would you like luminance or H alpha?
Let's go with luminance.
Okay, let's do 10 minutes on that one. Let's go crazy, because it is kind of dim. I call M78 the other Orion Nebula.
Yeah, way other.
Yeah.
But it's cool to see.
Off she goes. Yeah. We decided just to call the scope the KAS remote telescope. We thought about naming it after someone, but so many members gave money. We decided just to keep it kind of a neutral name and not name it after any one specific person.
Actually, I think we should name it after our two mascots.
Yeah. Yeah, we have two mascots currently that have been helping keep down the mouse population. There's a neighborhood roadrunner, an actual, meet roadrunner. And there's a bird house on Pishi Observatory, and inside that bird house is a I forget what kind of a western screech owl, I think. And he's been doing his fair share of mice eating as well. So we love those guys. Mike said the mouse population is noticeably down compared to what it usually is.
Good.
And apparently the owl has a name now, but the Roadrunner doesn't yet.
No, I named the Roadrunner Rhodey, but I don't know if anyone else calls it that.
Oh, that's right.
But apparently Mike Patton's grandkids named it, what was it, Danny?
Yeah, he said Danny.
The owl did, yeah, the owl.
The owl is Danny, yeah. I call the Roadrunner Rhodey. Not very original, I guess. We're working on that guide star. It's beeping away at me. I don't know if you guys can hear that. Probably not.
Should call it Roadrunner Chuck.
Chuck. Why? Why Chuck? Because of
Chuck Jones, the animator.
Yeah, I was trying to think of his last name, Chuck Jones, the animator, right? Yeah.
Does it get pretty hot there in Arizona? Like
the hottest I've seen it is maybe the mid 90s. I don't think I've ever seen it crack 100 because they are pretty. They're about 4,800 feet altitude.
Okay.
So pretty fairly high.
But it doesn't damage your equipment?
No.
That's good.
Let's switch to behind the scenes here. I never did. I usually stretch this out a bit so it's a bit bigger, but I don't know. It's acting really sluggish. Oh crud! That's not what I wanted to do. No, don't go that big. Well, the wind's down.
35 would be nice, but it's probably too big for the plane wave, though.
No, I'm trying. No, I don't think it'd be too bad. We can always switch to the Takahashi if we've spent the plane wave. Where I'm always happy to go back. Oh yeah, that's right. We're doing a 10-minute shot. So yeah, it's going to be a while.
The plane wave gives you half a degree?
Yeah, a little more than half. Yep.
That's good.
Oh, I wish I had maid service here. I need a refreshing beverage. I need an ear rub too. These headphones are killing the poor ears here.
You've got 10 minutes. Go get yourself a drink.
No, I can't leave my post. Wow, we still got 18 people on YouTube. That's amazing.
Yeah, they could
There was
actually join.
46 at one point.
Because I was about ready to kill the YouTube league, but if we still got 18 on there, they can hang around.
They could actually join on into the session now.
Yeah. So if you are on YouTube, of course you won't hear this for 20 seconds. You can
Right,
join us
right.
on Zoom now if you want.
Between Zoom and YouTube, we had 146 people tonight.
Wow.
Dang. It's been a pretty successful couple of days. We had over 100 people for the general meeting. We had about 400 people for the lecture today, for the lecture series, and then 142 for tonight. Phew. Someone asked, is the Starfinder a separate scope? By Starfinder, do you mean finder scope? Because every telescope has a finder scope that gives you a wider field of view, so you can find the object and see it through the bigger scope.
Might be talking about the guide scope.
Okay. So, yeah. So we have an auto guider that guides the stars for us. Not, of course, if you do any serious imaging, you have to have some kind of auto guider.
Somebody in YouTube said, "Don't kill the feed."
Oh, okay.
Okay.
I will not kill the feed. Pretty soon, the people on YouTube will start screaming, "Attica, Attica." We'll see that pop up on the chat here soon. I'm curious, is the KS involved with any specific viewing, charting, or other objective? Then it went away. Not really. No. Pretty much everyone does their own thing. We don't have anyone currently using the remote scope to, like do variable stars or look for asteroids or comets. So, there's definitely projects members can work on. So far, we've been being very superficial and just trying to take pretty pictures. Oh.
Some of the stuff some of our members do don't involve the remote telescopes, though, because some of us do observing challenges from the Astronomical League.
Can you guys see like series? Like, I mean, I know it's coming. Very close.
See what now?
The asteroid like series. I mean, I heard it's coming. Gonna get close to Earth.
Oh, the asteroid. We could. If we did, we'd have to do a series of exposures to bring out any trails in like a short 5-minute shot. It probably wouldn't move too much, but it might move a little bit. I've never tried to bag an asteroid yet, but
you need Vesta.
Or Vesta, yeah.
Yeah, Vesta's the one that's coming in March 3rd.
Okay.
Okay. Yeah, I can't remember which one, but is it possible to see with a telescope? Like,
well, you could probably see it now. It's in Leo.
Somebody asked why the gap with live viewing until November if it's been successful. We pretty soon we're going to start daylight time, and so we'd have to start like an hour later. And really, once we get into March and April, we get into the public observing session season, or we traditionally do, assuming no pandemic. So once we really get into April, especially, we just get a little too busy to do online sessions. And, frankly, if we had to choose, kind of cool conditions in April toward doing this, I'm sure most of us would prefer to be out observing the real thing with the public. Because I'm really excited to share our new telescope.
Yeah,
with the public. So we might do more of these, but they'll probably be more informal for members. And I remember last year when we really did get into the pandemic, we were doing some in May and June. We didn't start till midnight Eastern time, and we were doing some of the summer objects. So that was pretty fun. Of course, we had maybe a dozen people on here, but you know, it was better than not being able to meet up at all. Because yeah, we haven't met in nearly a year now.
We still have 52 people on right now, so
yeah,
thank
it's
you very
amazing.
much for doing this.
You're very welcome.
Plus YouTube.
Oh, we should let me check in how we're doing. Oh, we're getting there.
I see that you have a lot of tracking errors. Would that be a problem affecting the quality of the image?
No, probably the main source of the tracking errors is from the atmosphere, from Earth's atmosphere. So, you know, bad scene. This is a little squarish here, so that's kind of weird, but it should still look pretty good. Unfortunately, the little picture of the guide star does not update like it does in Maxim. But so this does change as it's updated very fast, and it looks like it's holding steady. So it's doing its job.
Yeah. Like if I want to compare the program with Maxim guiding, would that be better than the PhD2?
I couldn't quite make that out. It sounds like you're talking from a long tunnel.
Okay, I guess it's my internet quality.
Okay, yeah.
He asked if Maxim was any better than PhD2 for guiding.
Maxim's been around a lot longer, but PhD2 is really good. I've had no issues with PhD2 either, but we have to use Maxim with ACP, so we don't have any choice. That's specifically why we use Maxim. I have, with my own personal setup, I have an astrophysics Mach 1 mount, and I use PhD2 for auto guiding. And with PhD2, but more specifically with the Mach 1, I've never lost an image with that mount ever. That's how good it is. I love that mount.
Hey, with this M78, the Crab Nebula, how come, I mean, is it really truly the haze around it and then the darkness and then the nebula in there?
Yeah, so M78, it's not the Crab Nebula, but it's another emission nebula in Orion. It's a bit dimmer than the actual Orion Nebula. And yeah, it's basically a nebula that gives off light from the hot stars within. This one has a lot more dust, though, so it's a lot dimmer, even though it's roughly the same distance as the Orion Nebula. So that's why we're doing such a long exposure. I don't think I've tried 10 minutes before, so it should really make it pop out.
Well, on your screen, M78 is actually the one that's really dark with the white in it.
Oh, no, that is the Crab Nebula.
Yeah. So with the Crab Nebula, it's the haze around it, that's actually reflected light.
No, I'm not sure. I'm not sure exactly what's causing that. It could be light from Mike's place, or I'm not really sure. Because that should not be there. So that's curious.
It looks very interesting.
Yeah, it could have been gone in the next image. I don't know. It's hard to say. Oh, 1 second.
Yeah, for this particular exposure, which was 10 minutes, the guide scope was definitely of use, but you were talking about the tracking on the scope being so good. If you had 5 minutes or less, you probably didn't even need the guide scope. Is that correct?
I'm sorry, Don. I had to do something else.
I was saying that with this 10-minute exposure, we did need a guide star, but if we were doing less than that, 5 minutes or less, probably wouldn't even need the guide star.
Yeah, with the 20-inch, I think we can do maybe 3-minute shots unguided, but two for sure, but maybe 3. Oh, there we go. All right.
Oh, that's nice.
Wow.
Yeah.
Yeah. Oh, 10 minutes does a really great job. Oh, that's awesome.
Yeah, that's as good as I've ever seen it.
Wow.
I look at it with my telescope, you usually just see the middle part there, Don't even see the rest.
Do those stars reside inside that nebula?
Yeah, so it's these stars that are responsible for this thing glowing. Otherwise, it'd probably be very dark.
Mm-hmm.
They give off a lot of UV light, excite the gases, and actually make them glow. Yeah, that's
Are
cool.
these stars actually born in nebulas?
Yeah, that's why we call like the Orion Nebula a stellar nursery.
Yeah.
So there's like a whole cluster of stars in the Orion Nebula that, you know, are just now leaving the nebula. They're not even 1 million years old yet, which for stars, you know, it's very young.
Leaving the nebula?
Yeah, they'll gradually drift outward.
Oh, nice. Thanks,
good
Richard.
nebula.
Hey, Richard, if you want to end on a galaxy, we could probably do one in Leo.
Oh yeah. How's M81's getting high enough, but we could do one in Leo too. Do you want to do a Leo galaxy or M81?
M81 edge, partly edge.
Okay, so let's go ahead and end on a galaxy here. That'd be good. So let's do M81. I'm gonna knock it down to 5 minutes. That'll be more than enough. And off we go. I think I hit it. We're getting so much stuff here. I need to clean this up a bit. I'm not sure I hit it. Okay, let me try it again. There we go. Okay. So here, I'll show you a trick on how to clean all this up. There's all this, all the images we did here tonight. It creates like a little imaging plan for each one. You just hit fold and then unfold, and voila, nice and clean. That's how you get rid of that clutter. Oh, looks like we froze again. Now we always get the matrix view first, and then it goes to the regular view. There we go. You can see in the background here, this is Mike's 90mm Coronado hydrogen alpha solar telescope. I've never actually seen him use it, but I'm sure he has. And this is the case for said 90mm Coronado.
Are we going to be able to see both galaxies?
No, we can only fit one. Unfortunately, we can't get them both together with the 20-inch. We could with the Takahashi, definitely, but not with the 20-inch. Even that's too narrow. We got a big chip, but it's not that big.
I was just hopeful.
Maybe you do this one, and then switch to the TAC and take the other.
Oh, I guess I could do one more, but I'm getting tired.
Oh, I'm sorry.
Richard's had a long day.
We've had a long day.
It's been of course, I don't know if Dana should get the gold star because we had my kind of private online astronomy class on Thursday, then our meeting on Friday, then lecture series and viewing session on Saturday. So Dana, did you attend all 4 of those?
I attended all of those, and we went out to the John Glenn Astronomy Park when it got down to 13 degrees. I get the gold star for that.
Oh, you get 2 gold stars. Burr.
This is much nicer. You know, it's warm. The the coffee is right here. The bathroom is right here. I like it.
I see you got M78 behind you, so you have your own image M78 there.
Yeah, that's Royce, of course.
Yep.
Which stars are gold now? I'm confused.
You said I got a gold star.
Yeah. It's in the mail. Don't worry.
Alberio.
Yeah, there you go. I'll give you a golden yellow and a sapphire blue star.
Okay.
Okay.
Yeah, I was thinking if we had the TOC M65 and 66 over in Leo would have been a real nice target.
Yeah.
Oh yeah, sure.
But Richard's getting tired.
I'll keep going. I'm not quitting.
Yeah, if you go to the TAC, I'd say yeah, sure.
All right.
Because there's even that I don't remember the NGC object that makes the triplet there, but I don't know if we could get all three of them in one shot.
You should be able to.
Well, I never gave anyone
Yeah, it should be no problem.
a bit of a tour of the web interface here. So I've been using the single image because we've been just taking single images, but with the color series, of course, you can do, luminance and, red, green, blue, or blue with your number of exposures, your exposure, and you can have it focus automatically and periodically. So you can just let it run for a while, although it doesn't focus through narrowband filters too well. So this is how we do our more advanced imaging, where you set out a plan for the night.
So you just focus it once and don't bother focusing again?
No, it's good to focus every 60 minutes to 90 minutes. Usually I focus every 90 minutes. That's usually fairly good.
And is this system one that is made to run with your telescope? Is that why you use it with your mount?
Yeah, we mainly, we have to use the SkyX to run the mount, but ACP will work with many telescope controls, but to do auto guiding, you have to specifically use Maxim and camera control. But we chose ACP because it has the web interface, so you don't need to download any special software. You just have to have a web browser with an internet connection, and off you go. Oh, I better write down that we did M81. Boy, I'm going to have a lot of bonus images to do. We almost have as many bonus images as we do the pre-planned ones.
This just reminds me of regular public nights when we are done and just decide to do a free-for-all and go wherever we want to.
Yeah. Got the wrong view here. No, non-video. Oh, there we go. Okay, that's the view that I want. Okay, so now I can see more people, but of course, not most people aren't sharing their video.
You know how dark mine is anyways if I'd share, so.
Which one did I have? I got...
Everybody's in their pajamas.
Yeah. Well, at least they have pajamas on. That's better. Hello, Sarah.
I just don't have any lights on.
You're such a cheapskate.
Dark adaption, man. Dark adaption.
It saves on global warming, right? You're trying to save the environment.
Well, of course. Hey, at least I'm not the house next door, which is empty, but the realtors kept all the lights on.
Oh, that's stupid.
Yeah.
Who's paying the bill?
Don't care.
You're trying to keep people from throwing parties.
All right, just about there.
Getting there.
Yeah, there's no parties in my neighborhood.
That's because you live there. You're a party pooper.
That's because
true.
the lights are on.
No, nice quiet neighborhood, and we like it.
Oh, somebody asked about the file name. You can see what the file name will kind of look like here, although I take out my name, my initials here, and I put in the telescope so people know what telescope that we used, because we can't put that automatically in the file name. So we have the designation, the person that took it, which I'll replace, the date and time, the exposure, the binning, and the filter. Oh, it looks just like M78. Oh wait, it's not done yet. Well, what's there's a glare in there. That's not supposed to be there. That's weird. What is that?
Do we somehow get what? What the heck?
I don't know what that is.
Some kind of artifact, isn't it?
Yeah.
Oh my gosh.
Well, maybe I'll clone stamp that out later.
Are there fireflies out this time of year down there?
I have no idea what that is. That's a new one. I've never seen anything quite like that yet.
Some kind of artifact looks like.
Well, the galaxy still looks good.
Yeah, it does.
Wow.
Yeah.
Oh my god.
It looks
Cool.
like some bug that caught light just right and interfere with the image.
It
Right.
looks like a porch light, I think.
Yeah, Mike might have his. Well, he does.
No,
course.
it's not on right now, is it?
This takes one photo every 4 minutes, so that's not really an indicator if his light is on again.
Or was on while we were taking pictures.
I really haven't an exact clue what caused that. That's the first I've seen something quite like that. But the galaxy's still gorgeous, though. So
Yeah.
Oh, it's stunning.
Go to the talk and hit
Right.
65 and 66. Let's get that triplet
okay,
on the night.
Yeah.
Unless somebody else lets you want to stay.
all right. Let's. Okay, so I'll hit the switch to talk button.
Yeah, that should be some nice group. It's the M81, M82, and then 65, 66, and whatever in Leo.
I know it's an NGC object. Don't remember the number.
Yeah, me either.
A 3628. That's the other galaxy in the triplet.
Okay.
It's one of my favorite edge-on galaxies. So that's why I know that one.
It's too bad Corvus isn't up. I'd love the sombrero.
Yeah.
Oh yeah, for sure.
Yeah. NGC 4565 isn't high enough yet. That's my other favorite edge-on galaxy. You can't go wrong with that one.
891.
Yeah, that's a good one too. I always forget if that one's an Andromeda or Pegasus. That's easier. I think it's Andromeda. No, it's Pegasus.
891?
Yeah. No, Pegasus. I'm pretty sure. Oh, I can close PowerPoint now. We don't need that open anymore.
NGC 891's in Andromeda.
Okay. So I was right the first time. I'm not going to refocus, although focusing goes much quicker with the talk, so we'll kind of take our chances here. We do have to wait for the camera to cool to -20, though. So let's give it a little time here. It only takes a couple minutes for the camera to get to -20. It's already halfway there.
Mm-hmm.
You have to change the focal length setting again?
Oh, yes, I do. That's a good point. I am on it.
All I could think of was when you took the picture of the horse head, it was Magrathea from last night's talk.
Yeah, that was a good talk. She was a good, fun speaker.
Definitely. So she and the next speaker might have a little bit of a different point of view as to whether there are other habitable planets in our galaxy.
At least she didn't say they found any planets around Alpha Ceti. Because you know what's on Ceti Alpha 5.
Uh-oh. Yeah, don't go there. God. Where are we? Oh, okay, we're ready to go. Let's see. What should we do? Let me do NGC or M. I don't know. Let's try NGC 3628.
Well, Don wanted M8182 together.
We did M81, M82.
Oh, I thought we were going to do M65, M66. Okay, well,
Yes.
I'll do M81.
Yeah, but since we already pointed pretty much there.
Okay.
Maybe we'll get rid of the Firefly.
Right.
Let me knock it down. I'm going to knock it down to 240 seconds. Let's try that. Did I hit it?
So you remembered to change the...
Oh, yeah, it's gone. Yes, I did. I changed the focal length and the aperture. Yep, so we're good to go there.
Okay, good. Yep.
Here, I got the home computer set up the way that I like it. So you can see it's going to do a 20-minute or 20-second exposure for the framing. So it'll do plate solving and center to the target. So M81 should be perfectly centered.
It should be a wide enough field of view to get M82 in there as well.
Oh, and then some. Yeah. No problem there.
It was with a triplet, we may have to take a couple of tries.
Well, not necessarily. There's a way around that.
Yeah, you can recenter with the what the heck's that called?
The pictorial camera field.
Yeah.
It's here, so you can use this to kind of move it around and frame it where you want.
Okay, gotcha.
I don't usually show that too much during the online sessions because it's all in color, so it kind of outdoes the images that we take. Because everyone, you know, how come there's no color? All right, we'll go ahead and stop sharing here for a bit. All right, who's sleeping? Raise your hand. I'm surprised Frank's awake. Usually Frank's the first to nod off. He must be on the super caffeine tonight.
Took a nap before just so I could stay awake.
Oh, there you go. Well, you guys aren't excited at all, so let's go back to the browser. Oh, it's past midnight. It's tomorrow. Oh, and it's 5 after. We can see what the astronomy picture of the day is. Hang on. Whoa.
God, looks like
M53 from Hubble. That is a
Good
true
gravy.
remote telescope. So there it is, your astronomy picture of the day.
And notice it's got 4 little spikes out.
Yep. Same reason we have little spikes. Ooh, there's a galaxy. It looks like a galaxy right there. Just hogging all the glory. Oh yeah, who's gonna watch the Super Bowl today? Does anyone care?
Yeah. I'd like to see the old man win another one.
I
might be
normally
fun.
watch the commercials afterwards, and supposedly they're not going to be very good this year. So.
Yeah, that's what I heard as well. I've never been a football fan, so I will not be watching. I think the last Super Bowl I really watched was the 1985 Chicago Bears and the Super Bowl Shuffle and all that mumbo jumbo.
Right.
That's probably the last one I actually watched.
That was a fun
They've already
game.
showed all the commercials already, so there's not even any reason to watch.
Oh, really?
There is one funny one for Alexa.
Okay. I saw a funny Doritos commercial today where this guy has a snow globe and he's like, I see in my future free Doritos. So I gets the snow globe and throws it into a vending machine. And there you go. Free Doritos. Then another guy gets it. You know, he's shaking it and says, am I going to get a promotion? Then he throws it and he hits his boss in the groin. So obviously I don't think he's going to get the promotion. So I thought that was really good.
The Alexa one is they're all standing there and they're looking at the new design of Alexa, and they say something about, isn't this such a great design? It can't be any better. And this woman looks out the window and she sees a bus with Michael B. Jordan on the side, and all of a sudden she starts daydreaming about him standing there. And when she says, Alexa, how many teaspoons are in a cup? And his eyes do the blue, and then he says, there are 16 teaspoons in a cup. Just that kind of voice he has. And as it goes on, she starts saying, Alexa, turn on the sprinklers. And her husband's going, we're overwatering. Don't do that.
Did you mean kitchen lights?
They're all partying. They're having a party, and the guys are outside and the women are inside. And she says, Alexa, turn
Sorry,
the lights.
I didn't find a device.
And
named-
Michael, that's good. We got rid of the light.
Yeah.
Yep.
Hey, you can certainly tell the scale. I mean, this gives you a good idea of the scale.
Yeah.
Original size of our original image.
Oh my gosh.
I think you can see.
Richard, in that original image was M81 that light?
No. You mean M82, the light? No, that's too far out of the field.
Yeah, I
of
get
view.
them mixed up.
I've imaged
Okay,
M81 several times with the remote scope and never had anything like that. But you have M81, M82, and at least two other galaxies for sure.
Probably elliptical down there to your left.
Yeah, I don't know. That could be, but it looks like a star to me. But it could be.
Yeah.
I don't. But there's supposed to be like kind of Milky Way cirrus clouds in this whole region. I forget. It's called the Integrated Flux Nebula, if memory serves. But that would take several images to really bring that out. It's really, really faint. Yeah, so there we go.
Wow.
All right, let's go see the Leo.
Okay.
Yeah, for sure.
Let me try NGC 3628. That might frame it a bit better, but I'm not really sure. To bring out that galaxy, let's bump it up to 5 because it is fainter than the other two. So we might blow up the other galaxies a bit, but that's okay.
So then you can go down to that feature and frame it.
Yeah, it'll we'll see what it does, but it has to get there first. Yeah. Check on no, how come there's never any meteors? You can even see, I think the sky's turning a bit green from sky glow. That's a chemical reaction. Sometimes it can get pretty green because it does get really, really dark there. This zodiacal light is long gone.
So it's not green
Good night,
because
Dick.
it's
Good night,
jealous of
Jackie.
something?
Hi, Dick and Jackie. Oh,
Night. See you next month.
okay. Whoa. Dang, still got 16 people on YouTube. Hello, YouTube people. Oh, I see UFO. That's probably referring to the big streaky thing by M81. But I'm not sure it's
yeah,
flying. We can't really prove it was flying, though. But it is unidentified, so it's more like just a UO than a UFO.
It could have been floating.
That's true. It could have been floating. Maybe it was a roadrunner.
Unidentified fluorescent object.
He zipped by so fast, he was just a blur.
Unidentified fluorescent object.
Yeah. All right. Let's see. We should be there. Let's see how we're framing here. Oh, it's not. It's really wide, so we really shouldn't have to touch it all. It's probably going to be more like that when we're done. Oh, we couldn't find a guide star.
Oh my.
Yeah, it's pretty sparse in that area, but with 5 minutes for the talk, we shouldn't really need it too bad. But I could have framed it like that. Let's see what's around.
Now, could we get two of them in the 20-inch?
Yeah, I can get M65 and M66, but I can never get a guide star. But I could always move it around. I have done that before.
Well, no, I don't want you to do it. I was just wondering.
Yeah, I'm just saying. I'm not switching scopes, so.
Right.
Unless someone gives me $5 million, and then I would switch telescopes because it's $5 million.
Do you take Bitcoin?
No, or I don't take GameStop stock either. But maybe control that Jewish space laser. That'd be pretty cool, brother. Sorry to get a little political, but that just takes the effing cake. A Jewish space laser. Jesus Christ.
Everyone knows
And we
that
all
space
know
lasers
that
are
it's
non-denominational.
owned by the Martians,
Yes.
really. They haven't used it in a while because they ran out of the Illudium Q38.
What's that? Is that a sci-fi reference?
Oh my God. Come on.
I don't know all the stuff.
Isn't
Marvin
that
the Martian?
for what the little Martian guy needs?
I haven't seen Marvin the Martian in probably 20 freaking years. I don't remember all that.
Capture that creature.
We know.
Oh, that's very good, Kevin.
Space modulator.
Oh, and to think, after all the DeBrine impersonations I hear you do, you can do Marvin the Martian instead. That's much more fun.
I was a little disappointed in the Friday regular meeting that there was no mention made of my first planet that my brother and I, fake planet that my brother and I used to look in on the Rough and Ready cartoons for Mooney Moolah.
Oh, okay. Yeah, she didn't do everything on the list, so.
I mean, that one was so fake, it was just too fake.
And I always thought Krypton was around Antares.
I had never heard that. Oh, somebody wants in at 12:16 in the morning. I guess we'll let her in.
Oh, Sarah, yeah, she was here.
Oh.
I let her in.
Still 16 on YouTube. Of course, I count as one of those, so really 15 on YouTube.
Me too.
Oh, they say they're not sleeping on YouTube. That's good. We're gonna fill up the disk space on the YouTube headquarters with this session. I think the overtime, well, it's not quite longer than the main time, but it's getting pretty close.
I think this will be a good image to wrap up with.
Yeah. I'm still shocked we got 40 people on Zoom too. That's amazing.
I've always been a big draw.
Yeah.
Still snowing here in Grand Rapids.
Oh no. Oh, now I'm yawning. That's a bad sign. I don't know what I don't feel like doing anything astronomical. Maybe I'll watch TV. Maybe I'll watch a little bit of Cobra Kai again. I'll watch season 3 again. That was fun. If none of you out there have seen the Cobra Kai series, I highly recommend it. It's great fun.
What's it about?
It's basically a sequel series to the original Karate Kid movies in the 80s. It's on Netflix. It was on YouTube, but now it's on Netflix. It's so much fun.
You kids and your streaming services. We used to have 2 channels and we loved it.
We liked it.
And in black and
You had to
white?
get up and check.
Yeah. The boob tube. Oh, I think it's done. Bunka bunka. There we go. There's one bunk. There they are.
Oh, yeah.
Oh, wow.
It looks like a face.
It does look like a face.
There's one galaxy. So this, let's see. This is M65, I think.
Actually, it looks like
M66.
C3PO.
Yeah, it does. This is NGC 3628.
Yeah, that's a good image. Still seems, what is there? Seems like some kind of brightness around.
Yeah, I'm not sure what causes that myself.
Do you know when these objects were discovered?
Not specifically with these, but if I really had to guess, William Herschel discovered them in the late 1700s. If you didn't catch that from earlier.
But when they found these, they didn't. This was not defined as we're looking at it today, right?
No, when we first started discovering objects like this, they were classified as spiral nebulae. Or spiral nebulae. We thought maybe they were stars in formation with planets around them. We long suspected they were galaxies, but we really didn't conclusively prove that they were other galaxies until Edwin Hubble discovered Cepheid variable stars and the Andromeda Nebula, now the Andromeda Galaxy, back in like 1924. So our definite knowledge that there are other galaxies is still under 100 years old. But I can't say that much longer because we're almost at the 100th anniversary of our realization there are other galaxies.
Okay, and the big guy in the corner will then be this one here.
Yeah,
All
that
right.
that's probably an elliptical. That looks very galaxy-ish.
Yeah, I was going to say that's pretty freaking bright, man. I just don't remember another galaxy that close. Kind of odd.
These are not part of the Virgo cluster, just FYI.
The one on the left that's kind of in line with them is out of Leo, I think.
This one?
Yeah.
73 Leo.
73 Leo.
Okay.
And the one down here is
The bottom left.
Charton?
Charton.
70.
Okay. So it is a star?
Yeah.
Both stars.
Okay.
Both stars, right.
Yep.
Okay.
So 70 and 73, the intensity of the light seems,
Yeah.
Now, could it be that we're getting some sort of fog or some kind of
I have no
dew
idea.
or something?
Could
Gosh,
be, but I don't think so.
Yeah.
Well, that air glow.
Yeah, it could be.
there is a lot of wind, right?
It could be sky glow. It's not really windy. Wind doesn't affect the Takahashi that much.
Huh.
Yeah, but if you have a little bit of wind, I think you mean then you shouldn't have any dew on anything.
Yeah, well, the humidity is like 30%, so
Right, so it shouldn't be.
But you could have dust.
Yeah,
I mean, I
wouldn't
know
that pick up the sand a bit?
you can really get dust.
Yeah, they definitely get dust there. That's for sure.
Yeah.
Well, there we go.
All right.
Thanks, Richard.
Thanks, Richard. Appreciate it.
Thanks,
Thank you,
everyone.
Richard.
Great, thank you.
It's a great conclusion to the season.
Definitely. Good night, Richard. Appreciate it.
Yeah.
Hey, Richard, take the rest of the day off.